Hello, I am the Ronin Pawn, and welcome to a twitch.tv/Ronin Pawn live stream. On twitch.tv/Ronin Pawn, hey Wolfie. I was just wondering about that Autosplitter the other day. Yeah. It's been stewing in the back of my brain, and today I'm gonna take a look at it. I'm gonna take a look because I've been playing around. I can't believe I actually opened up Python, PyCharm, and started tinkering, but I've been screwing around with something. And, I think I can rebuild my engine 1,000 times simpler and way more efficiently and easier to work with and a whole bunch of other things. And, yeah, we're gonna take apart RP Split, which, for those who are unaware, is an auto splitter for speedrunning Clustertruck that I wrote out to beta and distributed to, you know, some people in the community to get feedback and tests and that kind of things. And then kind of just dropped because the issues that arose, I mean, in part at least, because the issues that arose were just kind of the kind of issues I didn't want to deal with. It's very specific, very hard to troubleshoot, and even by the time I'd reached beta, what I realized was once I had put in enough runs on my beta, it still was able to fail.
Yeah.
Prosecutor Walton from Ronin Pawn, import streaming Python. And Mosaic Task Force subbing for 25 months now. Merry New Year and a Happy Christmas. Happy thing and merry to you as well. Ooh, I got an emote due to your sub, and thank you for the sub. I got... the fuck is that? Haha, shrug left. Okay, we're assembling a haha snowman. Maybe when you put the whole thing together, there's any reason whatsoever for it to have haha before it. Maybe there's something funny about it, Twitch. Maybe at that point, there's something. Anyway. Thank you, Mosaic Task Force. So yeah, we're gonna be looking at some code today and tinkering. So it's gonna be, you know, really exciting live stream with the for loops and if-then statements. Shit, man, hold on to your fucking chair. But yeah, this is what I'm doing. So, you know, in your usual time slot for a Harvin Pawn show, which we're still a little bit ahead of it. I'm starting early here, but Harvin Pawn, Wednesdays at 4 p.m. Eastern, 9 p.m. BST, or, you know, just sort of UK time. You know, Harv and I are on a sabbatical, a hiatus. We closed out the first season after doing like 16 episodes or something. And, yeah, so this is what we're going to be doing today. Hello, Pawn. How was your new year? Says Lord of the Ying. My new year was, you know, fine. Just spent on the couch. Basically, I did manage to get out before, like, the liquor store closed and buy some more beer because I was out of beer for a couple of days. But that's basically it. I laid on the couch. And, the most interesting part, which is just old hat to me and, you know, not a big deal anymore, is that every New Year, every time that the New Year rolls around in Detroit, what we like to do, apparently to celebrate, is come out of our homes with our semi-automatic and fully automatic weaponry and fire into the sky. So, you know, New Year's sounds like what Detroit looks like in most areas, a war zone. So, you know, you're lying in your house listening to pop, 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 pop. You're just listening there, and you're hoping that everybody keeps pointing up and waiting to see whether or not something's going to fly through the wall or a window. People are always safe with guns, aren't they? But yeah, that's how we do Christmas or New Year's in Detroit, and I was just lying on the couch, wondering if I maybe should move into more of the middle of the house. You know, I got solid walls. It's not fucking paper, you know, by which I mean drywall. There's plaster, baby, so, you know, you'd need a high caliber and you'd need to be, you know, intending to shoot at it in order to penetrate. But, you know, there's windows and stuff. The cats are sitting up there. Even the cats are like, oh, yeah, it's just Detroit, you know, hearing, like, in the distance, pop, 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 pop. And he's like, huh? Oh, right, New Year's. So, just like Mexico and dinner, when it's dinner time, everybody, hey, it's dinner time, pop, pop, pop. I don't know if that's, my sort of very outsider's perspective on Mexico is that it's more of a sort of mañana-based economy. Don't worry about it. We'll get to it. And I think I would do well in Mexico, and if not Mexico, then Spain. And there's my New Year's resolution. I need to get the fuck out of this place. I can't do another winter here. It's killing me. Thank you for being a great streamer, entertainer, artist. Oh, well, thank you for saying that, Mosaic Task Force. I often question basically all of that, so I'm questioning you right now, but I'm also, some of it is getting through, I think. Oh, thank you. Yes, fire the guns, says Wolfie. God bless America. Yeah! Always stay under cover. Well, I was under the covers. The covers, however, were made of cotton and wires, because it's an electric blanket, and bullets tend to pierce that. But like I say, I'm not that worried about it. My biggest thing is, like, the fact that we do that every New Year's means that every New Year's could be a really good day for the purge, basically. In Detroit, taken on by private enterprise, by individual citizens, basically anyone who you wanted to kill, just wait until New Year's in Detroit if you want to kill somebody in Detroit, and then nobody will question anything while you're pop, pop, pop! You son of a bitch! Pop! Like, they'll just be like, oh, it's New Year's. It's a very viable, if you're running some kind of nefarious underground sort of organization, and there are certain people who may or may not be moles or rats in that organization, then, if it's sort of like, late November, just wait it out. Wait it out, and there will just be nobody will even, dispose of that body at your leisure. What am I talking about? A soft entry to programming is Factorio and Big Pharma is Mosaic Death. Well, we're not going to have a soft entry here. We're going to have a hard, deep, kind of an entry. Programming is a mindset, and those two games are about combining elements with constraints to make a bigger system. That is exactly what programming is about. I absolutely agree, though, with that comparison, yeah. With Factorio and Big Pharma, and I think Factorio is, a better representative of that. Big Pharma is a little bit more contained, which can actually make it more, entertaining in bite-sized portions than Factorio. Factorio is kind of, Cracktorio. It's kind of an addictive thing that you get into, but the joy of it is putting together a very comprehensive mechanical system to do and make logical choices for you and things like that. So, yeah. We are going to be looking at my Python code today for SplitRP, and what I should have done and didn't do is open up Clustertruck so that I can show you what be all with the doing of and the SplitRP. And I've got the other Autosplitter installed, so that's probably going to be problematic. But we'll see. So, Clustertruck's starting up right now, but in the interim, I can show you SplitRP as soon as Clustertruck gives me back my computer. So SplitRP is an auto splitter for speedrunning that I wrote, so that, it would, and there it is. There's, like, our non-graphical interface, which was just going to be in the beta for, testing and things like that. You were going to have this up so that we could see what was going on for bug testing and things like that. But this is SplitRP. The point of it is that each level that you complete in or in Clustertruck, it will just automatically go to the next level in your splitter for you. Which is, we've already got that in the auto splitter that we use now. But the reason why I actually got really interested in it was that if this auto splitter were to work, its primary, its big contribution would be creating basically an IGT % category for Clustertruck. We could time speedruns based on in-game time IGT, which would remove the time that you spend in level complete screens. Because there is like, half the fucking skill of speedrunning in Clustertruck is getting your mouse to the corner and clicking the next level button as quickly as possible between levels, especially when you're running segments. And, a missed click there ruins a segment run, and the slower you are on that, the more time you're losing. So there's that. But that could be considered a skill in speedrunning. You gotta click this button in order to move to the next level. Okay, sure, whatever. And make no mistake, I'm very good at it when I'm on. Sometimes I'm sloppier than others. But more importantly was that an IGT percent like that took out the time you spent on level complete screens would make it so that how powerful your computer is would have less of an impact on a speedrun in Clustertruck. It has been very decisively determined by Snakeathon and AJ and several other runners that if your computer is just a little bit slower, you know, if it doesn't process quite as quickly as the next guy's, then you can be losing, 6 to 8 frames per level complete screen. Something, possibly even more, but, sort of average it. Say it's just 6 to 8 frames to load time of the next level. You get to the next level complete screen, it pops up, you click next level, your computer's a little bit slower than the next person's, 8 frames lost. In a game that goes across 90 levels, 90 times 8, at 60 frames per second, is not an insignificant amount of time that you're losing to the fact that you can't afford or don't happen to want to spend your money on, a computer that's going to be that little bit faster. And I think, and my PC, I believe, is just a little bit slower at running the game than some of the other runners. I have to turn all the settings off in order to get the maximum out of it, and I just don't want to. But so there is like an effect of that on speedrunning where it's not as much about the game as it could be, as it should be. So if this splitter were to work, then we could start timing things based on how much time you spend in level and take out that rush to click the next level button as being significant, and also take out the impact that having having money for SD and RAM and good graphics card and CPU and all that kind of stuff artificially places on the skill that you show in the level at the actual speedrun. So that's what actually got me interested in taking on this project originally. Ronan Paul, the programmer. Yes, he's stepping in, isn't he? Let's see. Oh, gifted sub ends today, so now I'll have to watch an ad or something. Oh, Wolfie. As for real programming games, I bet Pawn can recommend some. A soft form one is Human Resource Machine. Yeah, we've done that on the live streams, haven't we? I'm a big fan of Zachtronics. You look into just Zachtronics games in general. Very good programming games. The further you go back, the more it's going to be like your hand will not be held. So more modern Zachtronics games are going to have more polish, more UI, just things that are going to make it easier to get into. But that's my big recommendation for programming stuff. Ronan Point, you lose a lot of time to clicking the next level button than most, I'd say. I definitely, from day to day, I have a lot of trouble with it. I mean, there are certain runs where I watch him back and it's like, yeah, boom, 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 he's nailing them. But yeah, I do spend a lot of, and I'm just losing tenths of a second to it, pulling down and going a little bit too far because your mouse appears here between each level. You pull down, you go that far down, you just missed your fucking next level click. You gotta hit boom, right? No, boom, right about there. And maybe a little bit more to the left because the next level button is broken in fucking Clustertruck too. So if we could take that out of the run, it would be great. If you want to program for real, not a game, then try making a program that does a repetitive task that you are bored of doing all the time. This is Mosaic Task Force, just recommendations, because this is a program, not a game. And basically that's what it does. Guess who left the stream open and came into the room wondering why the hell a video is playing? Oh, I've done that before myself, Kenneth. I think, oh god, I think for some speedrunning conference or something, I had something open that just had, the rules of submission on it, and I just kind of left it open for a good long time, thinking about whether or not, and then they started up a live stream one day, and I'm like, what the fuck is going on? Somebody got a back door into my computer? It took me a minute to put that together. I'll come up with something in some time and do that. This is Wolfie to Mosaic about the thing. Even the in-game timer is a bit off. Yeah, that's true too. The in-game timing is not quite correct. Snake consistently gets in faster than Spittle due to having a better PC. Yeah, I don't know what the hell he's done either, because I got a pretty beefy fucking PC over here. And, you know, I think it's not even just about money either. You know, it's about fucking just happening to have maybe luck into or be so profoundly just into it that you've got the right hardware. Because I load Clustertruck off an SSD, I got gobs and gobs of RAM, you know, I never get anywhere near using all the RAM that I got. I got an AMD Ryzen 7, I got a GTX 1070, and Clustertruck ain't the most fucking, you know, anything heavy game that you could be playing, and yet, you know, my loading times are definitely a little bit slower than Snake's. I think me and Snake have about the same load times as Wolfie. I think mine are slower, just a little bit, and I've done very deep dives into looking at runs and load times and stuff, so... But I think mines are a little bit slower, and I could get that back by turning off all of the visual settings, but I don't want to. Because I do a live stream, and I'd rather it look nice. I like it that way. I downloaded 100 grams of RAM off the internet. Oh, did you? That's a good way to get it. So this is SplitRP. This is the application that I developed. This is the UI that I created for it. Carrot has also a subscription 3-month streak going. Thank you. I has a carrot. $year++. That's true. That's where we are, isn't it? So this was my UI. I spent a lot of time coming up with the code to support this user interface and then graphic designing it, and way too much time because... But it was something I was into, I was having fun, so I created this. So this is your settings menu where you can change certain things in order to get it to do what you want. I've got an auto clicker that you can turn on and off, which will automatically click the next level button for you, which would be fine in an IGT% category because it wouldn't matter. So I just threw it in. Various things here to determine whether or not you want to make sure that the game is active. There's all kinds of shit going on there. You can control your reset key. But what we need right now is it's looking for live split. And I do have live split open. But what I need to do is turn the server on so that it can communicate. And now live split has made a connection with my program. My program has loaded up the file that it runs on. Now, I have two different files for this that I did, two different config files that I wrote for it. One is just straight Clustertruck config. So we'll start with that. I'm just going to leave everything as it is. You're not going to be able to see any of this once I get Clustertruck open, but you'll be able to see its effect on live split. In fact, since you can't see it, I'm going to pull this over here so that I can see it. And you know what? Maybe... Let me just quickly see if I can't do a window capture on SplitRP. Not on the program itself, but on that, yeah. So... let's just have this as a thing that's there, and I'll put it below me in the scene. But we'll have it there so that we can see what its output is as we're running. And then I'll be able to see the actual thing. But okay, so Clustertruck. So right now, what does it say? It says that we return to game, and then the game's not active when I click out. So that's one of the things it detects. The way that this splitter works is it is watching your main monitor. So it's watching the monitor to see what's going on, and then it's using a series of patterns that I've hand hard-coded in for it to be able to detect the difference between this screen and it actually, I think it might actually know the difference between these two screens, but this screen. So now we've come into the ready to begin area because we're on, you know, that. And yeah, you can't see that happening, but there's things happening. So if I come back out, then it knows it fucked up. It thinks we're speedrunning and it started the thing. So there are holes, there is sloppy stuff going on in this engine, but it knows that we're ready to begin. So it won't start. It started early. When I start it, And here's the thing, I've also got the regular auto splitter in place right now. What am I doing? I don't know. Just walk it out. If I go over to in live split, if I switch this over to game time, we're currently paused because we're in the next level screen. So it is stopping time, and then when we re-enter the next level, boom, it starts again. So it's watching every single frame of gameplay and then, well, and then analyzing it to see if we've entered or exited the level. And you can see there in the splits that it's already up to level 3. That could either be because of problems in my detection, or it could be because I've got the regular auto splitter installed in Clustertruck right now too, so it's sending double signals in. That could be a thing. But yeah, so this already supports the idea of in-game time. It's just not particularly consistent, is the thing. Just like my speedrun right now. I'm not even trying to run. I just want to get through the levels to show off the fact that, you know, it pauses itself and then carries on as soon as you exit the level. And if I, you know, go out of the game and come back into the game, it doesn't unpause itself. And you can see that it's recognizing we've left the game window, so I'm not gonna, you know, waste processing power detecting things. Now we're back in. I just checked the frame. We're still on that same frame, so I'm not gonna unpause. Now we've unpaused and we're back into the level, so I'll start timing again. So all these features were there in the beta build. They were just, there's an inconsistency. It's not usually this inconsistent, so I think we are getting double signals from the auto splitter that's installed as part of... No, don't save any of those times. In fact, you cleared out... Oh, well, because this is IGT. Because this is IGT, so there aren't any things there. But, so that's basically what it does, how it works and everything. I'm going to close it down now, because I just wanted to show you what it was doing. And for now, even, we're going to get rid of live split. We don't need it. Do I want to save my splits? No. That's cool. Is the analysis using OpenCV? I assume there's a combination of methods at play here, says DannyT66. And you are dead on. It is using OpenCV. Now, what we're going to look at here today is actually not, well, what we're going to look at right now anyway, is actually not the code for SplitRP. It's not the auto splitter. It's something else that I was playing around with. And the idea was, can I do image analysis based on what I learned while I was writing that auto splitter, to do a no green screen chroma key. And there's software out there that does this already, but, you know, I was curious, I was interested, can I write that? So I started to write comparison methods for taking an image that you would take a snapshot of the background, and then, you know, without you there, and then you would step into the shot, and it would simply try and compare the difference between your background and you being in the background in order to just find you and green screen out all the rest. So I was playing around with that. I never really got anywhere, you know, great with it. I plugged in some, you know, face detection and a whole bunch of different stuff. I played with it for a while. But most importantly was that I, you know, built out comparison algorithms around a similar premise to what SplitRP is trying to do. So what I've just sort of realized today that I knew months ago, like I was thinking about it months ago, but what I've tested today is my ability to do everything that I've been doing in like 5 lines of code instead of an entire fucking, you know, couple hundred. And at a much higher frame rate. So what I've got here is I got all these different like functions and things, and then down here actual code running. We can look at that in a minute, but I'm just going to show you what we're doing right now. So this is comparing bg.png to streamer.png. And in fact, let's start with red and red test. And I'm going to pull open those image files so that you can see what it is that I'm working with. This is red, okay? And this is red test. So those are the two different images, and I want to compare them in a way that's fast, that's quick, and that, you know, my idea was to reduce the fidelity because the things that I was thinking about, I didn't want it to be perfectly accurate to start. And I didn't want it to try to be perfectly accurate to start because the amount of, like, clock cycles that it's going to take for it to be perfectly accurate. No, I want to, like, limit the area that I'm working in. I want to find ways to cheat the system and, you know, do this faster. So those are the two images that it's going to be comparing for us. I'll run it, and the first result that we get, it compares the two of them, and this is basically a comparison map. And this comparison map has been generated at a resolution of 18 by 32. We've blown up this map. It's an image, but it's just being used as a map. So there are 32 squares from left to right and 18 up to down. And this is denoting where things are different. A black area is there's no difference whatsoever between, you know, between the two images that are being compared. Anything that moves toward white or into the grayscale is there's a difference there. And what we've got down here that I've just like whipped together today is a comparison of the image similarity. Mathematically, this is 98.708 and so forth on. You know, same, the difference between the two, 98.7% the same. And this did this in about 83 frames per second. This is using the methods that I hand-coded, hard-coded, developed myself, tinkering around with different methods. This is my, like, hand functions. Now we're going to do it with just built-in OpenCV, which I was using OpenCV before, but this was just me coming to a couple of conclusions and going, wait, I'm doing that just longer-windedly. They've already got methods for that. So now what we've done is we've just compared the two of these, not grayscale, but in full color, which means it's looking at 3 times the amount of values, because you've got red, green, and blue, or in Python speak and OpenCV speak, blue, green, and red, because they're all fucking backwards from what we all say for some fucking reason, and it just gets really confusing. But, so that actually did the comparison in, you know, color, as opposed to grayscale, and it came out with a image similarity of 93.62, because it's looking at color difference as well, and it did all that in 200 frames per second. So the other one was working on pure grayscale. This one's working on full color. It's faster and more descriptive of the reality, because it's you know, also describing the difference in color and not everything that's been smashed down to just, like, luminance. I do image analysis as part of performance testing for work. What you're saying, Ari, cutting down the area, is spot on. We know, for example, in our code that the bit that will change is always at the top middle of the screen, for example, so we only ever focus on that area. Some screenshot libraries do RGB, some do BGR too, yeah. Dealing with the fucking BGR and RGB shit. You know, you think you're operating on one color channel, and then 20 minutes later you go, oh, that's why nothing's making sense. But yeah, so this is taking the full, you know, 1920 by 1080 image, and what it's doing, that is different in this second pass, to come out with these results, is instead of all the shit that I've been doing with just manual, I mean, there's small functions. It's not a lot of code here. Small functions, but I've been doing it manually. And I realized that one of the big things, let me show you this again, in my first pass, what's going on here is I am manually in my code taking each one of those squares and basically doing a mean average of the values within that pixel space. So it's summing up all of the, after they've already been compressed to grayscale. So you've just got values that go from 0 to 255. 0 is black, 255 is white. And it's taking all of the pixels that exist in the image in a certain square, and then adding them all up, and then dividing them by the number of pixels that were in that square to get the average result. And then putting that into this new image, which is small. It's tiny. It is literally the resolution size that's stated in the code, which is 18 by 32 pixels. So this image is 32 by 18 blown up to the size so that we can see it without going, huh? So my code does that like 1 by 1. and it moves through the different sections, and it creates a lookup table so that it doesn't have to do math twice and all kinds of shit in order to look at those different squares, get their average, and then represent them as a single final number in this smaller image map of differences. And what, dawned on me quite a while ago, but that I kind of just rediscovered and started actually playing with today, was that I have just described the process of shrinking an image. I've just described the process of resizing an image. You take the values around, it's one of the methods. Take the surrounding values around a certain area that's going to be shrunk to a size, and then add them all up, take the mean value, boom, now you've got the average of that, and now you've shrunk the image, and you can just declare that pixel that number. Which means, why the fuck am I not just using OpenCV's built-in resize method instead of doing all the things that I'm doing in order to make that happen? Because I have to take I want it down to, what are we doing at it again? 18 by 32? I want it down to 18 by 32. Okay, so 18 by 32, but it's 18 is the size of the final thing. So from there, how many pixels are in the original, and then we divide and do this and that and the other thing, and then loop through with, for this, for that, on the X, on the Y. I'm doing all that shit, and I realized I've just built my own, scaling algorithm from scratch, which is necessarily going to be slower than the stuff that's built into the library. So that's the big change here, is that I'm just using the library to just resize it. But also, all of the comparison comes down to, I'll show you the code that does the second pass, which looks like this, which actually analyzes color difference and represents that visually for us, and gets this far more realistic, 93% similarity because of differences in color value. Here's all the code that does that. There you go. That's it. It's all the code that's required for all of that. And some of this code doesn't actually have to run at runtime. Because what I'm doing is I'm taking the background image, and I've called it small BG, because it's going to be the small one when we're done with it. I've taken the background image, and I've resized it to be whatever the resolution I've declared, and it's 18 by 32 right now. I can change that, in a heartbeat. Then we'll start our timer so that we can get an estimate of how many frames per second this is actually doing. Then we'll do the same thing with the foreground image, except for I don't actually need that line of code here. I put that in to see how it affected the processing time if we were doing black and white. So actually, if it took 166 frames, if we do it without the grayscale conversion, we're back up to 199. Now we're up to 333. It's a little bit sketchy when you're just doing one pass and trying to guess at how fast it would be. So there's 249 frames. But we don't need that. So actually it's one less line of code than this. So we resize the small one, or the background, we resize the foreground, then we simply subtract. And, this is supported, I think, by OpenCV. Just subtract the foreground image from the background image, and it's going to take all of the values individually that are in that image and subtract their values between 0 and 255, black to white, against the values in the same position in the other image. So just subtract the two, and it does all of that in one sweep, and then I'm just printing out, I'm doing the final math in line as I'm printing out the values that we found. I'm taking the average of similarity by then summing up all of the values that we've got there, which represent the differences between the two images, 0 to 255, sum them up, then divide that number by the number of pixels that there are in this image, times 3, because we got 3 color channels, and then, in order to make it a percentage, it's 100 times 1 minus, because what I'm doing is taking 0 to 255 and turning the 255 into 0 to 1, making it just a, decimal kind of a thing, and so we have to do some little math to push it in the direction we want for the right output. But yeah, all of that happens in just these lines, basically. I got, importantly, 1, 2, 3, 3 lines. I mean, the fourth one is calculation, and it is doing a sum. So, all right, 5 important lines. Gets done everything that I was doing before, and it does it slightly differently. Let's actually do this in grayscale. You're making me want to dig up OpenCV and actually learn how to use it, says I Am Greaster. Let's switch this back to grayscale, because I was doing everything in grayscale before. So if I have it do BG gray and FG gray instead of just the background and the foreground image, at the resolution that we were having before, and then I take out the ×3, because we'll only have one color channel, no color channels, we'll just have, you know, the representation of luminance, I guess you could call it. That should do it. If I run it again, I broke it. What line? Line 114, gray, CB2's color, FG gray is equal to, oh no, I want you to be from FG, and then it would be small FG needs to come from FG gray. I just had the wrong variable names. So now we get basically the same result, at least to within like 1,000th decimal point there, 98.70, 98.7089. So they're both getting basically the same result when they're working on grayscale, at least on this image, and this will change in just a moment. I'll show you more. And this one's doing it at 333 frames per second. Here's another thing. Let's just run that again. Still at 333 frames per second. If we raise the resolution on this calculation, and I'm doing this, the reason it's 18 by 32 is we're in a 9 by 16 space, you know. 1080p is 9 by 16. So I'm doing 9 times 2, 16 times 2. If we go down to, let's do 9, 16. Let's do a really small, you know, blocky image like that. My code did it in 142 frames. That code did it in 250. If we run it again, I'll bet it goes 333. 250? 333. Same amount of time as the higher resolution thing. Let's make a big jump and go 9 times 5 is 60, and 16 times 5 is... 9 times 5 is 45, you fucking idiot. And 16 times, I was doing the second bit of math, is 80. 16 times 5 is 80. So 45 by 80 at that resolution. Now we're getting a really, you know, there's some crispness there. It's getting down to the edges. That took my algorithm, or my functions, 20, you know, I'm only getting 22 frames per second that I could do that at. I could do this one at 250, which is it's a familiar number. Oh, there's 333 again. Oh. So, like, could we go 90 by 160? I haven't actually tried this yet. 90 by 160 I could do this 6 times per second. That's how long it takes my algorithm to go. And it's looking like does it in the same exact amount of time. OpenCV's. Oh, look, that one came through at 500 frames per second. Run it again. 6 or 333. So it's going to be somewhere around there. Like I say, if you're only doing it once, it's hard to get, you know, an accurate estimation of how long that's going to take. So yeah, now things get a little bit more interesting, we could say. Let's take this back down to 18 by 32 for now. A little bit more interesting when we do like a background. I told you the reason I was making this was to see if it was possible to do a green screen without needing a green screen behind me. And I know it's possible. Other coders have done it. Other people sell that for like $29. You can get it online, a thing that does that. But I wanted to see if I could code it. So this image, the two images we're going to compare now look like this, which is just the background of my office from a while ago when I was working on that, and this. Like a picture of myself looking like an idiot. But so it's just me in the shot and me not in the shot. There's a little bit of difference between these two frames, you know, even though very little has changed in the shot, things are going to have changed in that shot. So there's differences in the folds in the fabric, the colors and the values and things like that. So let's run it against those, BG and streamer.png. And at this resolution, this is the map that my algorithm turns out at 99 frames per second. It says that there's an image similarity between those two images of 89.4%. Lots of black here, which means there's no difference. Lots of a little bit of gray, and then these are kind of halfway to gray. And I'm not exactly sure why mine turns that out, whereas, I mean, they're both mine, I wrote them, but whereas when I'm just using, like, native OpenCV, these are the results that I get. So much starker contrast on these grays, to high whites. And, yeah, I'm still not sure off the top of my head why that happens. But so now we've got an image similarity of 73.2, which is far more, like, I mean, you can look at it, you can eyeball it and say, yeah, so this is... It's almost 50% of the side, and then you got a lot here and a lot here. Yeah, it's probably 75%. It was not. It was never 89%. You know, the fact that I'm in the shot makes it just... It makes more sense that it should be different. And this is just in grayscale. Again, we can do this in color, and there's almost no performance difference. But yeah, let's try crank it up on this. Let's go to 45 by, what is it, 45 by 80 on the resolution, and it will take my algorithm 24 frames. I would get 24 frames per second out of that. You can start to see me in the image where I have created a difference, but my difference is, it's not stark. And then in this one, it's seeing a lot harsher differences where it detects differences. It just did that at 332 frames per second. Instead of 24 frames per second. Let's go to... let's just go back to 18 by 32. And let's actually do this in color. Again, let's do the second one in color since it's not that big of a deal to add it. So what I need to do is I need to account for the fact that there will be 3 color channels. So we want the number of pixels times the number of color channels, because that's how many values are going to be summed in this, calculation. And then we want to basically just don't, small FG should come straight from FG, not FG gray. And small BG should do that as well. And then FG gray equals to, we don't need that code at all. And this should give us color. Now we're in color. And my small image similarity is very wrong. It's negative... Did I put that on the outside? I put that on the outside. Put it on the outside of the parentheses. Times 3, run it again. Oops. Alright, well, I mean, it ran, but I wanted to leave it here. So, image similarity is 71.0%. And the image similarity is very similar between grayscale and color. There between the two things, but 250 frames per second, I just analyzed it in color, and what we're seeing is the differences in colors is represented, across the 0 to 255 RGB spectrum. So let me scroll back up. Let's see, you're making me want to dig up OpenCV. Oh man, this code is a complete Clustertruck. It very much was. And this was all testing code. This was just crap. This has nothing to do with, this was never in my SplitRP. Well, if I show you SplitRP, that's a Clustertruck. Minuscule performance change, but if you do your calculations for similarity and frames per second, then print them after, you will gain a slight performance increase. Printing to the console is actually quite a heavy operation, especially at scale. Ah, okay. Yeah. I'll keep that in mind for probably later today when we're doing that. Python has a timeit module which will repeat something several times and give you an average time. I could write a quick loop to do it myself, but I am familiar with that. It's part of the standard library, so I could just, boom, okay. Isn't this more or less what H.256, H2, is it 6.5 rather, video compression does? Looks for differences, and then only notes the differences from the last frame to the next frame instead of noting the entire thing. There's definitely some continuity between there. Hello, Turnitin. Looks like a guy in green hair that is on fire and holding a gun. Yeah. He's holding, okay, so he's holding the gun out in that direction. Or, okay, he's got 2 guns, and this one's pointing out there, and the other one's shooting at your face. And that's where the fire is coming from. He's wearing goggles, too. But yeah, just a few lines of code gets me, you know, this. It gets me really fast, more accurate similarity testing. So, what I have been doing in SplitRP, um, I don't even want to show you the code. I think showing you the code would make it harder to make sense of it. So I'm going to pull up instead. What are you going to pull up? I'm going to pull up one of my config files, and we'll have a look at that. So if we go into, if I open this with Notepad++, and bring you over here, and actually maybe so that more of it is on screen, more toward the center. So if we look at this is handwritten. You know, everything that's in here describes things that SplitRP tests for in order to confirm, in order to decide that it is on the correct screen. So the way that this works is for the level complete screen, okay, we've got, is it enabled or isn't it? Do we want it to be tested or don't we? We've got the area that it will be checking. So that's taking the screenshot at 1920 by 1080. Where do we want to look at that from? We want to look at it from 623. It's doing something. I can't remember if that's width, height, X, Y, what's going on there. Origin. I think, okay, so origin would be the XY. So 230 pixels in, 30 pixels down is where we start. The area that we want is 623 wide, and then 1 pixel large, because that's all that the level complete screen is looking at. This is looking at individual pixels. I've got a max value for how many pixels it will scan from that point before it finds a black pixel as opposed to a white pixel. The level complete screen is mostly white. What this is doing is trying to find the word level on the image. And it has to look for it because at the end of every level, the level complete screen pops up, but it shakes for, you know, just user interface, for just effect. So you come in and it shakes randomly too. And I think it depends on how hard you hit the level playing goal, how fast you're moving, stuff like that, or just completely randomly, I don't know. But it shakes. So level complete will be further left, further right, further up, further down, but it will also be at different scales because it's scaling it too. So I don't know exactly where the word level is going to appear on that final screen. So we know an area where it's going to land, you know, it's going to be there, somewhere in there. So we're going to a certain area on a certain line, and we're looking from left to right along that row of pixels for the first pixel that when we thresh it, so if it's more white than it is black, it'll go white. If it's more black than it is white, it'll go black. Once we thresh it, we're looking for the first pixel that is hard, absolute black, after being threshed. And then there's all these little tests that I'm telling it from the point where you find the first, like, character, the first black pixel. I want you to look for something negative 186 pixels, you know, 186 pixels to the left, 77 pixels to the left, 92 from the middle. And it's actually more complicated than this, because I built in a centering module so that the scaling would be less of a problem. So basically, first we find the first black pixel, then we jump into like a certain distance in, and from there find the first black pixel, so that we'll be looking for, like, instead of the L in level, we'll be looking for the V. And I actually think I rewrote this to focus on the word complete, but it doesn't matter for the sake of the example. So we're looking for the letter V, where that's going to be, and then once we find that, we know that we need to jump back. You know, we expect to find black pixels here, 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 and here. And go find those pixels, and if they're not there, then we're not on the right screen. This is not the level complete screen. And the reason why I did it that way was because, you know, it's really, really specific, and it's low overhead. You don't have to consider a large, you don't have to look at the whole friggin' screen. You don't have to do math on all the pixels, on all the color channels. You thresh it down to black and white. You look at one row of pixels. It seemed like this has got to be a really fast method that I could do a lot. I could do this a lot on each individual frame in order to test a lot of different possibilities. Are we on the level complete screen? Are we on the credits screen? Did we go back to the main menu? Did we go to the pause menu? These tests needed to be done. So this was the method that I came up with, was to look at very specific areas of the screen and test for very specific pixel values at places where I could expect them to be once I oriented, once the algorithm here oriented itself in reference to something, the word complete, the word level, something that pops up on that screen every time that you go there. So that's how this system works. It's not a comparative system. It is a edge detection system. It is what we expect to find if this is the screen based on what we know, and that's what it is. It's not very smart. It's just driving toward efficiency and least number of calculations and get her done. And I want to replace all this with what we've been looking at, which is a, smarter comparative analysis, which would rely on a percentage truth about either an area of the screen or maybe just the whole fucking screen. Maybe we got enough processing time to do it. Maybe it's not going to be like a significant overhead. I don't know. We'll see. But doing a comparative, like percentage-based, is this screen, and then this file would get so much simpler. Because you'd just be saying, like, here's the file that you'll be comparing against that's stored on the hard drive, and look at the screen, and every frame, check that one against this one, and if it's upward of 96%, then that's a positive. Do a thing. And it's not as simple as that, but it's nearly as simple as that. And incidentally, I'm not the first one to have, this isn't anything new. Even for, what I'm talking about is for a speed-running Autosplitter. There is another Autosplitter out there that was developed by somebody that is built around this very premise that I'm just now, like, coming onto and saying, this actually works pretty good. So I'm late to the party here on this. But I don't think you could use that Autosplitter for Clustertruck because of the unique, difficulties that face Clustertruck and because of the unique signals that you want it to send to maintain IGT% and regular percent. Maybe you could. I don't know. It's been my pet project. It was at one point, and then I just walked away, so I don't mind coming back to it. Danny says, I'm going to have to hop out for a bit. I'll be back later if you're still live. One thing you may be interested for the splitter, not so much for this, is looking into D3D shot Python library. It's Windows only, but it's the fastest way to capture a screenshot in Python, and basically records the same way OBS does. It may be the most efficient way to capture the game screen for the splitter. Side note, though, it's RGB, so you'll need to flip it. Well, thank you, Danny. I'll keep that in mind, and I guess I'll look into it. I went through a number of different libraries, looking for which was the fastest, and the one that I am using presently, or that I was using, shit, I suppose I'm not actually using it for any of this code. Maybe I've still got it in the imports anyway, tabbed out, or... Is it MSS? Yeah. MSS. I tried different things. OpenCV's screenshot is slow as balls. NumPy, I think, has a screenshot taking thing that's slow as balls. MSS gave me the kind of frame rates that I was looking for. But I will actually write that down as something to check into for optimization at some point if I end up running against that. And I hope to see you back here, Danny. You've probably been gone for 10 minutes already. I think H.264 also does it. Heck, even MPEG-1 does it. Yeah. Very much a standard method of trying to encode video for smaller file sizes is to look for differences as opposed to, trying to just store the whole damn thing or do a JPEG style compression on it or something like that. So yeah, these are the results that we get when we've got one in grayscale, one in color. This one's a lot faster. It's very small amount of code. And, my thoughts, I come back to Notepad++ here and just like open a new one. What do we need for this? Like, can we sort of whiteboard this just in Notepad? Because what we'll be doing is we'll be taking a comparison based on sum of differences across an area. So, and it will be percentage based. So, we'll just be taking that percentage, and then, that's part of the information that we need. So if we head down here, like, what we imagine the file structure would be like, I've actually already had some thoughts about this. So, like, you'd have a primary match equals, 94%. And you wouldn't have 94, you wouldn't have percent, you wouldn't call it this, but you'd have, like, primary match. But then you could also have, and should also have for our uses, a secondary match, because the Clustertruck, screen, during level complete screen, it moves around, it shifts, but also over time, if you stay in that screen, things start sliding on, the level complete board comes in, words start appearing and moving around. So having the ability to match something and say, we need a really hard, rigid match, we need a high level, a 94% match on the first find, but then on every frame past that, in order to maintain that match, maybe 86% is enough. So having a primary match and then a secondary match, 2 different numbers. Hey, I came from seeing a special Clustertruck video and seeing you got screwed over, man. Yeah. Hello, the new Slayer. Yeah, Apollo Legends coverage of that situation. This is actually what I ended up doing, developing this splitter off of the heels of that, because I was, it's like, fuck, I don't even want to run. I don't want to look at Clustertruck, and I couldn't keep myself from looking at Clustertruck, so instead I started developing this Autosplitter, and now we're back. And so is UI grap. So yeah, we'd have a primary match, we'd have a secondary match statistic. We would have also, do we want to do this in full color or grayscale? So grayscale equals true. We'll do it in grayscale, because we can, the beauty of this is that with these, just a couple of lines of code, like, it's still very simple. You can either shove grayscale stuff through it or shove color stuff through it. The values that I have to change in order to switch it from grayscale to color, very few. And the biggest thing that you have to do is make sure that if you are doing color values, that you are multiplying by the number of color channels in the file, which is an easy calculation that I did in SplitRP development at some point. Or it's not a calculation, it's just an easy thing to reference once you know where you can reference it. It's either like the length of the array might give you information, or maybe it's declared in the array for the image itself. I don't remember, but you can pull that data out of it, or maybe, and I'm starting to remember, maybe you have to test for whether it's there or not. And if it's not there, then there's no data, and so it must just be a mono, But not difficult things to get. So we'd have primary match, secondary match. Is it grayscale or not? Is there an area that we want to be looking at? And you could do this as a bounding box kind of a thing, which would be, 00, 1920, 1080. So you could set that as, instead of taking the full screenshot, we're just going to look at a smaller space, and that's what we're going to compare against. What else would you have with a system like this? Whether it's grayscale, whether it's a smaller area, the first match, the second match. Like, I'm already straining to come up with things that are needed, and this is to be compared with this, where one section had all of these different things, where I'm talking about, like, what's the shade? Are we looking for blacks or whites? 0 or 255? Where are the edges we're looking for? What about the planes fields? So these are areas where we want to see all white or all black. So there's a plane, and then we're looking for edges. What's the soften? How many positions off of exactly where we expect to see the edge are we willing to tolerate? Maximum values, threshold values, things like that. With this method, so far, we need 2 different match percentages if we want them. We need grayscale if we want it. We need an area if we want it. What else would go into this? I feel like there's more here, but there's not a lot. I've recently discovered that color coding becomes extremely non-trivial when you need several distinct colors, like 10 plus. For what application? What are you thinking of? Talking about in hexadecimal or, you know, JavaScript, HTML kind of stuff? Or how do you mean? Didn't you already do this like months ago? Yes, I already did this. Well, I didn't try this. That's the thing is, like, we got this whole application built, and I'm looking at ripping the guts out of my incredibly complicated engine and just throwing this in. And do you know how much easier that would be for people to take what I have, to take this application and use it for other things, as opposed to just Clustertruck, just what I build it out to do? Because what you'd be doing then is, there we go. So, like, compare image is equal to images slash image dot image. You know, this is, you just have like a screenshot of what you want it to match, and then tell it how much you want it to match it for the first catch. Tell it how much you want it, you know, as an optional thing, the secondary match, how much of a match is required to maintain that match after first discovering it. And then, you know, these couple of different things, whether you want to look for it in a specific area or grab the whole screen, whether you want to analyze it as grayscale or want to do it as color. It's dropping images into a directory and then tinkering with some percentages. You know, maybe bit flipping on grayscale to see if it works better or worse in another way, and that kind of a thing. So this kind of an engine would be a massive simplification to what we were already doing and gives for far greater flexibility. The only questions, you know, it comes down to whether or not this is going to be accurate enough. And I think it will. I think it will. You know, with the level complete screen, if it's not accurate enough, we just crank up the resolution that it's doing it at. And we've seen with this code, with this simplified code down here, it's like this stuff. Down here, that simplified code, like, I can crank the resolution up no problem, and it doesn't, you know, it doesn't significantly impact frames per second. It doesn't look like it's going to significantly impact frames per second, because the only, like, the hardest thing that it's doing is resizing the image. And that's it. And then it's doing some subtraction across a large array and some addition across a large array. And then just some basic fucking, you know, calculations. So there's not a lot going on here that's high overhead. But that's another thing that we'd want in here would be the percentage of the matches, and then we'd want the resolution of analysis. So, you know, in this instance, we'd be talking, with what I've got over there now, 18 by 32. Or 32 by 18. But, you know, 18 pixels down, 32 across. That's the other thing, is that these, the arrays, you tend to think of things in terms of horizontal followed by vertical. So when you're dealing with images in Python, you know, it's an array, multi-dimensional array, so you're thinking, you have to think of it as vertical followed by horizontal. So it's 1080 by 1920, not 1920 by 1080. And then you've got OpenCV and I think NumPy as well operating on BGR values instead of RGB values. So the colors are flipped and the ratio is flipped. So rather easy to get that confused in your head. But these are the only factors that you'd need. It would just look at an image. You know, if you built out the user interface, all of this could be configurable in the user interface. But I'm not necessarily interested in building out my user interface for that. I know that the other Autosplitter that I've seen, just sort of video, I've never installed it, but I've seen talk about it, and I think I've seen a YouTube video, that kind of thing about it. Basically already looks like that's what it was built out for. Let's see, just finding 12 different hex colors that are all distinct from each other but show up on a white background took some effort. I wonder if Windows Spy would be in it. Nah, that wouldn't be particularly be. Hello, Drag and Drop TV. I'll be honest, I don't know what half this means, but I just feel so bad I feel like staying around is the least I can do to say that sucks. Oh, that's fine, the News Slayer. I mean, we usually actually run Clustertruck and don't program things that interact with it. Programming is awesome, this is Drag and Drop TV. It is indeed. So yeah, just tinkering with that. This is what we've got. This is my old algorithm, my old methods that I was playing with for a completely different project than SplitRP, and then this is the new one, and the difference is right there. 90 frames per second versus 332 frames per second. Image similarity, it thinks it's almost 90% the same, even though I'm sitting in one of the images and I'm not in the other. And then the better method, the faster method, also gives us a more critical comparison, you know? It errs on the side of, nope, that's wrong, which is good. And we can control it grayscale color, and it doesn't seem to have a massive effect on the frames per second, which is very shocking because all of the calculations that it's doing have to be done 3 times over because there's red, green, and blue values, and yet I guess just summing up these values doesn't take, especially because the final image is so small, so it doesn't take much time at all. I already need to pee. We've only been here for like an hour, and we've just talked about it. We just walked around it and sniffed at it and said, isn't this interesting? I haven't even, like, popped open the SplitRP code, which I'd love to show you how fucking complicated and convoluted and crazy it is, and we will. But I already need to pee, so we're going to take a live stream break. I know one thing on binary code. It uses 0s and 1s. It does. It does indeed. We're going to take a 7-minute live stream break. When we come back, I'll actually pull out the code for SplitRP. I got a couple of things that I want to do. We'll get to that in the next, hour. But stick with me. Pawn not out. am the Ronan Bond, and welcome back to twitch.tv/RonanBond live stream. On twitch.tv/RonanBond, we're a programming today, and drag and drop TV. If you want to learn something useful, learn to count binary on your fingers. By doing this, you can count to 31 on one hand. Let's see. 0, 1, 2, 3, 4. Oh, I like 4. 4 is good. Happy New Year! So Drag and Drop TV with 100-bit cheer. Thank you very much, Drag and Drop TV. So we're in Python. We're a coding. Well, we're tinkering with some code. We're going to anyway, and apparently I've already broken things. So first off, let's get a new file going. Let's start a new. Oh well, how do you do this? It's been a while since I actually coded in here, so we'll get a new just file, and we'll call this main12.py. And I'm going to copy over. Why are you in there? Okay, no, just put you out here. Oh, I've put it in the wrong place. I put it under scripts. Well, then just delete that. And then down here, new file, main12. Oh, pi. I don't think I need to type the .py, but I did anyway. And then we're going to go back to main11, and we're going to copy everything over, and we're going to reduce this down to exactly what we need and nothing else. NumPy. Do we need NumPy? Possibly not. We don't actually need MSS. I'm going to just comment that out. We do need CV2. We do want time. Apparently we don't need the screenshot, but I'll leave that commented out. We do need show image. We shouldn't need this. None of those functions should actually be necessary for what we're doing with this much simpler method that's just relying on libraries that already do this stuff and do it well. And just realizing that we don't need to do it. Noah Dodge, will you be an AGDQ? I will not be an AGDQ. I didn't even submit. Oh, I'm a bad speedrun. I mean, what would have been the point? There's no way they're going to accept on the heels of a controversy. Somebody's running a thing, because it's not, they got enough problems just trying to get the thing to hold together for 7 days live content without having to throw in people, chatting about, oh, you should do this guy? And then did you hear what happened? So that wasn't going to happen whether I went in for it or not. Print options, I'll leave those as they are. Here we're bringing in the background and the foreground images, so we're just loading those in as whatever we want. We've got our resolution declaration, cell size, odd dimensions, don't need any of that. The bootstrap, even map, odd map, no. Result map, we don't need any of my maps. BG gray, affecting color channels, don't need that anymore. BG gray, converting it to gray. It's an optional thing, we'll leave it in. Blurring it, don't need that. Yeah, don't need any of that. Even lookup tables, odd lookup tables, that's all gone. Main code. Start, the time, FG gray equals color. Nope, don't need that. We took out that process, that function. Don't need this. I'm just going to trust if it's commented out that we don't need it. And then look back at these. Blur, don't need it. Don't need the blur. Even difference map equals map differences. Nope. Even image, don't need you either. Straight to output on that. What we want to do is basically take this code, which is our, code that we give a shit about anymore. In fact, it's all the way down to there, I believe. And we don't need any of that as output. We just want that. Merged, print, output, none of that shit's necessary anymore. So, we load in the images. Where do we got that? Declare variables. We load these images in. Here's the resolution we're going to use. Bootstrap, we convert the background to a grayscale. We start our timer so that we can get an idea of how long it takes for this to run. Foreground gray equals, so we're converting that to grayscale as well, which is a thing that we don't necessarily need to do. Let's go to the simplest. I'll just comment this stuff out for now. Let's go to the simplest possible implementation of this. And the simplest possible implementation of this doesn't even resize. It might be that the resize processes take longer than just processing the full resolution 1920 by 1080 image, and the only function of the resize is to sort of soften the difference values that we're getting back for areas by grouping them as sections. So it could be valuable, it could be helpful, or you could just soften your percentage value. You could just lower your percentage match value and maybe not need to do that at all. So we'll have that as an optional thing, but for now, let's not resize any of them. Let's literally just take FG, or actually, was that small out? Let's just do out is equal to FG minus BG. And because it exists in a image space something, they're absolute values, so they can't go negative. They will go where they're supposed to go. 127 minus 255 will result in 128. But it won't be negative 128. Python uses tabs instead of braces and end comments, right? Tabs instead of braces, yes, it's all done with spacing. End commands. End commands, not comments. What do you mean by end commands? It's all just done with tabs. Yeah, absolutely. And I love it for that. I really like how they've just limited everything down to its bare fucking minimum. And also forced everybody to code within sort of a very similar convention. So we do the subtraction. We're still operating on full color values, so we do have this times 3 value. We get the approximate frames per second. And then our out, not small out. Ooh. So this is actually going to be, wherever we've got small out, it's just out. Okay. You'll be resized at the end so that we can see you. We're not actually resizing anything right now. The resolution could go as well. 960 by 540, easier on the eyes. Interpolation, nearest, sure. And we've already printed the capture time. So we could do end equals time.time, as was suggested earlier, instead of calculating the end time while we're doing it once we're done. I mean, the thing is, though, end time should kind of be... This calculation should be done first. So we'll do this calculation outside of here also. So that's going to be similar percent. I don't know. Similar percent equal to 100 times 1 minus the sum of out divided by 255, then divided by the resolution times 3, except for our res is not going to count for this. So just to make things work, I'm going to jack you up to 1920 so that I don't have to delete a bunch of stuff that I'll probably end up that I might end up putting back in. So we'll do all that stuff, and then we'll have the end times. Start, out, do the calculation, end, and then we can print the value of similar percent, and we'll just, print the approximate frame per second. I don't care if it takes you a minute to do that, and then the other thing will be showing the image. Does that run? Well, wait a second, you're running the wrong program, Pawn. Alright, yeah, that's the thing. Run main 12. Okay, on what line? Line 45, small out is not defined. I was sure I was going to miss one of those. So on 45, we just want you to show out. Go. So there's the difference. Anything that is nearer to black means that it's very, very similar, and everything else is a color, sort of negatized, I guess. Whatever the difference is in the color, you'll see the difference and not what matched. And it's telling us that the similarity of those two images without any processing whatsoever is 69.76%. It did that in 76 frames per second. It did that in 83. So there is a value to resizing it. We do save processing time by not having to do all of that summing across the entire 1920 by 1080 image. So that being the case, and I'm kind of glad to find that out because it means I didn't waste, a ridiculous amount of time. We add back in these. We want, well, yeah, we kind of do want to use those, and then out will be equal to small and small, because they're very small, Okay. And that took longer because it tried to resize it to one of these sizes, but what we want is something a lot smaller than that. We want, let's say, 9 times 8 would be 8, or 9 times 2, 18, 16 times 2, 32. And so we get a much more, lower quality kind of comparison, but the function of this, the reason why I started here and then backed up to see if I didn't have to do it is, one, we have to do less processing apparently, but two, also to soften those values so that there can be greater difference, greater deviation between things, without it necessarily like driving us far out of our image similarity values. So that's good. It reduces it. We control the resolution. That's all the things. And then we have the option of grayscaling this stuff. So you do FG gray is equal to CBT color. Yeah, so that's just the repetition of that. So we want this here as an option, because we could do, if we did, let's just go ahead and have it be BG and FG. Yeah, so that it replaces them so that we don't have to change code. And then we could do the same analysis in grayscale, and here it came up with 499 frames per second. So it could do that 499 times in a second. Really? 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 So that is, a pretty substantial improvement over not changing it. 333, 249, 333, 334, 249. So yeah, limiting us to that color space, to the grayscale color space, is going to, holy shit, it did it in 1,000. So probably the truth, wow, lies somewhere between 500 and 1,000. Probably more toward one or the other. I don't know. I'm out. My wife is back. Good luck, Pawn. Thank you, Drag and Drop TV. Thanks for showing up, and thanks for dropping the bits. And Happy New Year to you as well. I Am Greaser says, here's an angle to consider. Is it a pain to get the level ID and timer and whatnot from the Clustertruck.exe? It is impossible to get what we need, is what. Well, I've not looked at it, but other people have looked at it, and Clustertruck's usage of memory space, which is how you do that, it's impossible to orient yourself correctly to know where in memory space it's going to have the values that we would need to be able to look at, is what I think AJ was finding out when he was working on that. In terms of embedding something into the DLL, we've already got an Autosplitter that basically does that. I think the problem with building into Clustertruck is that it doesn't have the signals that we need built into the game. I mean, maybe it does, but I'm certainly not fluent enough to try and, dig in and create an embedded DLL kind of a thing. We need, for IGT %, we would need to know when you have cleared the level as a distinct difference from when you're sitting on the level complete screen. And from my experience with editing videos about Clustertruck and things, the end of level happens actually several frames before the level complete screen comes on, because the timer stops counting. So that could be a good indicator if you could tap into those values. And then you wouldn't get any of the level complete screen stuff, and you could cut it as soon as the timer cuts itself off. Getting back into the game would still be a problem, though, because when you click the next level button, the Autosplitter goes to the next level well before you're actually in the level, and then what you're recording there is level load time, which is a big part of what my attempt was trying to get rid of, was trying to give us IGT % where the power of your computer didn't matter, So if your computer loads slower into the level than the next guys, it won't affect your end time. But yeah, it has been tried, and trying to tap into like things that are active in memory didn't look like it was going to happen, at least from AJ's perspective. So, do we need NumPy? NP, so I do use NumPy somewhere. NP dot. For the summing and the print options. I wonder if OpenCV would have its own sum thing. I wonder if I've tested that before to see which was better. I don't, fuck it. But so this is basically our short form, comparative analysis program right here. Apparently most optimal is to do it in grayscale, to do it with a lowered resolution. Curious now to see if we jack that resolution up so it, there's more values that it has to look at. Still at 499, still at 499, still at 499. So we can jack this resolution up pretty good. So if I just went to 90 by 160, just did it 1,000 frames per second. 499, 1,000, 1,000, 1,000, 1,000. So, like, certain values and because of the resizing that's going on, they're going to be easier on the processor, easier on, if it's tapping into the GPU, however it's getting it done, they're going to be easier on it. And that could just be a magic value. It could also just be that it doesn't have to resize as much. And there are kind of magic values in here with resizing and stuff like that, because you're on a 16:9 resolution, and if you're trying to rescale it to a different resolution, then it's going to have to do different, weirder math to calculate how much of this pixel's value should be considered, because we want like a third of the value because it's on the edge of that, and we'll add that in. So the math gets trickier, and certain values I have tested for hours, going through just the values one by one, seeing if one of these resolutions was better than the other, and found that I could actually get higher speeds, faster processing times, out of higher resolution values that were actually, causing, there's more work for it to do, but it was doing the work faster on each pass. So there you go, there's main 12. That's all we need, and it's actually a little bit more than what we need. We don't necessarily need to set the print options like that. We load the stuff in. I'm bootstrapping the background image. I'm doing that before we get into like timing how long it takes, because that is an operation that can be done once on the image, the first image that you're going to compare against. You get that in, you do whatever processing you're going to do to it, and you're done with it. In fact, the fuck am I doing? Oh, well, that does happen before the timer, but I should put both of these up here. Yeah, because we force it to grayscale, and then we resize it, and that's well before we start any of the code. Why am I doing this twice? Start equals time, foreground, oh! Yeah. So we start it, and then you're not output. You're part of the primary calculation. Yeah. Output just needs to move down there. Just formatting now. So, we start the timer, foreground gets converted to a grayscale, then we make a new one, small FG, where it's been resized to the size that the resolution has told it to. Then we produce our out map, our out image, by simply subtracting small foreground from small background, subtracting all of those values individually, each of their pixel values against one another, and then calculating the similarity percent by summing all of those values together, dividing them by 255, because we are on a scale from 0 to 255, so that'll make it a scale from 0 to 1. Then divide that against the total number of pixels. If we are doing grayscale here, then actually the image similarity has been very wrong. Well, it's been processing like that, because, yeah, it's supposed to be 74%. because we're not doing all 3 channels of color data. We've gotten rid of them, so taking out that multiply times 3, so it's actually 74% similar, which is more correct. And then we end the timer so that we can just print out the values. And then we show what we saw, show it so that we can, see it, because it's fun to see. That's the whole fucking thing. And then this little function is just, makes it easier to call show image when you need it. And I'm only doing it down here once, so we could get rid of a lot of that if we wanted to, but we won't. That's it. That's the engine. That's the engine of, SplitRP if I decide to actually continue working on it. So let's actually look at SplitRP. Open in this window, just save everything else. Pretty sure it automatically does that. So, welcome to SplitRP. This is this program. So it's a lot of user interface stuff. It's a lot of, different, you click here, things happen, you click there, things happen, you mouse over things. There's a lot of shit going on here. There's communication with the live split server that needs to be embedded into it. So right here we're looking at the GUI. This is my GUI code that just, makes it look the way that it looks and makes sure that when you click things, it goes and does what it's supposed to do. That GUI code uses this library that I wrote while I was coding this that I called GUIable, which creates a whole bunch of different texturable buttons and backgrounds and just makes it easier to code in Python when you want things to look cool. What did you do there? Flatten trucks? Squish. And with a purple back. How'd you do the purple back? Oh, because it's a highlighted, because, yeah. But yeah, so this is a library that I hand wrote, and there are some bugs in there that I'm aware of, but I just got to a point where I was like, I'm fucking done with it. So there's the GUI, but the actual, code of our program that runs shit, this is it. SplitRP, the sort of main thing that calls to everything else. So we've got a click function, we got a change mouse speed function, a get mouse speed function, live split client, and all of, this class's features of connecting and sending and receiving. We've got the class of the Autosplitter itself and all of its functions. There's a lot of functions because I built it as a very object-oriented kind of a thing, I guess. And then down here, the initialization, when that actually happens, is we start up a frames per second timer, start up a frames per millisecond timer, we call the live split client, we start the splitter, and speedrun.main loop, and then everything happens from in here. Now this is calling out to screen monitoring? Yeah. Where I'm doing my screen tests. This is basically the engine. If I recall, yeah, this is basically the engine room of the program right there that we can now replace with basically 10 lines of code or less. Based on, but this is, I was doing edge detection, I was doing pattern matching, I was detecting solid areas separate from detecting edges, extracting certain rows of pixel data. That's the engine room. Everything else is just built around the engine room to make it work. Little timing function here that made things simple. Seconds to hours, minutes, seconds, hours, minutes, seconds to seconds. A frames per second timer, a stopwatch timer. Screen monitoring, that's the engine room. Config handler, this turned into a much bigger bullshit fucking chunk of code than I wanted it to be. Just to get the data in and out, to be able to save data changes back to the file, and to load file changes in from my config files is like 2.5 pages worth of code, and it doesn't need to be all of that, but I wasn't familiar with doing it, so I started writing it, and that's where we ended up. To do? Oh, our old to-do list. So, the bugs that we found out, here's all of the to-dones, by the way, starting down here. What did we do? We tried without monochrome conversion, no change in CPU utilization, additional issues arose, so we kept the monochrome operation. Built-in optical character recognition. That's how I started this. That was a waste of time. Resort glyphs, that's optical character recognition shit. Looser level complete recognition. Just pounds and pounds and pounds of, like, things that needed to be done that I was checking off as I went. And at the end, we were left with UAC launches admin to enable input blocking during click actions, because I should show you this, since, you know, this gets very boring. I should show you one of the features that I built in last minute, very buggy, very glitchy. But one of the features that I built into SplitRP. So we'll start that up. We'll get live split open. We'll open splits for the full game. All worlds. Give me the longer layout. No, actually don't, because we're monitoring this output here too, because you won't get a chance to see that. I'm going to control, start server. We should connect. We connected. So the program is now connected with the live split server. I'm going to move it off. You'll be able to see the text output anyway of it. Actually, and what I'm going to do is I'm going to load in the file Cluster Roulette. Cluster Roulette, people. You ready for this? Are you fucking ready for this? So, it'll probably break the first time we try, but here we go. Cluster Roulette, go. Okay, apparently the game wants to start us on level 9.6. This function, I wrote it like in the last 48 hours of development. I realized that it was something that I could do if I wanted to put the effort in. So, you know, extra 48 hours worth of development. Wow, it has been ages since I ran this stuff. So it randomly selects a level so that you can play Clustertruck in a random order and have to try and deal with that shit. So it's watching, you know, every single frame here. What are you doing? You know how to run this level, don't you? Come on out to you. Off of you, into the goal. Ah, I didn't quite make it. Wow. 110. I'm just not in, like, a running mind at all. Hands off. It goes to World 610. So this was, you know, Cluster Roulette. But it's very buggy, very glitchy. What level are we supposed to be on? We're on level 60, which would be 610. Because if you start at 1, level 1-1, then level 2-1 would be 11. 6-2, is that where we're supposed to be? Yeah, we're supposed to be on level 52. The thing is that it's very sketchy. Basically, if you move the mouse or the keyboard too much, well, if you interact with the keyboard or the mouse while it's trying to change levels too much, then it's going to, you know, hit the wrong button. It will do its own thing incorrectly. And that's what that reference was in the to-do list, was to set up the UAC credentials so that I could basically lock you out of your mouse and keyboard while Cluster Roulette was doing its thing. You need to have, you know, admin privileges to do that. So level 7-9, it says we're supposed to be on World 69, so it's actually hanging together here. It's actually doing what it's supposed to do. Shocking. Cluster Roulette, baby. Cluster Roulette. Think I can make it. Yep, I made it. I don't want to get sucked into actually playing, you know, a game. That would be entertaining. But it is pretty fucking cool. You know, the concept here is absolutely the shit. And that I managed to get it in part working in 48 hours because of the engine that I've written. I was happy. I felt happy with me. Where are you gonna go now? 14, which would be 2-4. That's correct, level 14. And, you know, it's doing this just based on simple math. It randomly rolls a level that it hasn't been to from a array list of all, you know, of levels 1 through 90, I guess, right? And then it says, okay, if the place where I need to be, you know, if there's 10 digits between me and the level I'm supposed to be on, well then I click the next, I click the arrow to go to the next level on the menu, And then, you know, once I'm on the right screen, I just click on the position that's associated with the number where I'm supposed to be. It was a very simple implementation last minute, and if my engine were a little bit more solid, and if I were to integrate, you know, this program asking for administrator credentials at the beginning, and you choosing to give it to it, then this roulette would work pretty perfectly. But, you know, those are the things that we need to work on if we want this, this auto splitter to be a thing. What are we supposed to be on? Level 30? Level 30 is 310? Yeah, I suppose that's right, isn't it? 30... 1, 11 would be 2-1, which means 20 would be 210. Yeah. Yep, it put us into the right place. I'm always questioning whether or not it puts us into the right place. Ah! Up, over, through and out. Where are you gonna take me now? Take me to level 75, aka 85. Oh, I was just going too fast. But that's the thing. That's what it is. Do you want to update your times? No. And I don't want to save those splits. I'll just close that down. Don't save anything. That's SplitRP, ladies and gentlemen. That's how she does what she does when she does it.
I don't need your handouts. I'm an adult.
In the year now, if viewers are still around, if Ronan can survive, we may find. Ha ha ball, happy new year.
Your ball is happy. In the year 2020 now, if viewers are still around, if Ronan can survive, we may find. Happy New Year. Thank you, little magnets. 2020 friggin' bits. Happy New Year to you as well. And to all a thing that they enjoy, I suppose. Exapunks? No. Python. So, how would we even go about developing on this new thing? How would we even start? Have you ever made a Redshift game with it? Redshift? What's a Redshift? What's a that? What are you talking about? What is it? If I double click here, do I get the where is you project? There we go. How would we even start fucking trying to integrate this? I guess we'd get it looking at the screen again. It's like I want to copy the project because I don't want to fuck with anything that's here. Could I just resave the whole project separately? I mean, it saves versions of files and stuff, but good God, the Redshift was that garbage fantasy console in Exapunks. Oh, right! No, I haven't made anything in Redshift. I didn't program a damn thing in the little Redshift Game Boy style console. But yeah, thank you again, little magnets. It's awesome. Make a squash truck emote so we can squish and reverse. Oh, Mosaic Task Force saying, with an exception for the final Satan level, yeah, in that cluster roulette, you would not land on 910 until the very end. That would be the final level. And that would also be how you know that you got to the final level. But like I say, bugs, inconsistencies, not solid and stable enough for my own speedrunning. I didn't use it. Once I realized that it could, once every couple of runs, or even more frequently, it would fuck up and it would do a double split, and then your times would be all fucked up. How would we even dig into this? I mean, it's just start ripping shit out is what it is. If took you and is there not like a save as option here? Wow, look at all those fucking files. See, basically I want to not work in this file. I just don't feel good about that. Can I, if I just copy and paste, New SplitRP. And then if I just close you down, were I to run you, would you even run? Yes, you would. Okay, there it is, running from, you know, code here. Everything doing what it's supposed to do. Okay, do. So, in this file, I mean, that's one thing, though. Like, we would... It's the engine that we want to rip out. So, click, change mouse speed, get mouse speed. Wouldn't touch that. Live split client, wouldn't fuck with that right now. Autosplitter. States and stuff, that's gonna be the thing there. That's gonna be the thing. Oh god, it's such a big job to get... Is it all in one folder? It is! I could just copy and paste the folder. It's such a big fucking job. You know what? It's all on fucking GitHub anyway, as it is right now. I didn't change anything after I put it on Git. I don't think I did, anyway. It's such a big fucking thing. How would I get into it? I guess just grind through it from here. So the auto splitter, we've got states and last state, last detected, last reset, active buffer, keys down, number of keys that are depressed, all shit that I shouldn't have to fuck with. Load file shouldn't really be a thing, but self.standby monitor equals screen test. File.start screen, file.standby patterns, pre-run monitor, and run monitors. These are objects that when we load a file, we create these objects, we make them into memory, and then they do shit. So screen tests are kind of where we'd get in. I just feel like this program right now is too fucking tight in the way that it interacts with everything to be able to dig into it and get anywhere. So what I'm sitting here thinking is, do I dig in here, or do I build outside of what's here? Try and establish, get the basics working, and then once I've got the basics working, then come in here and rip out fucking wires, because I feel like if I start ripping out wires here, I'm gonna end up... Where are you gonna end up? I'm gonna end up, you know, just in a place where there's so many bugs and so many things going wrong that I'll never really get to the point where I can even test and see if things are working. So I think we shouldn't be in SplitRP right now. I think I want pieces of SplitRP open, but I want to be in the chroma key. I could do it in a new window, and then I could have SplitRP open there, and then, yeah. What I should do then is create a new project. So if we go new project, and this is going to be new SplitRP engine. In this window. Shit, am I gonna have to do all my imports and stuff? External libraries? Yeah. Probably. Alright, well, give me a new, not scratch file, user, the virtual environment, include library scripts. Yeah, just give me a new file. Main one! Text file? No, a Python file. .py, okay, Python. And then if I copy paste all of our code into there, I will need to do some things with this, with the file locations and whatnot. So open you up in Explorer. And back to the PyCharm projects, no green screen, chroma key in the virtual environment. We want the images directory. Includes... That would be nice, but I'll put them in, I guess, the right way. One at a time, you know, I think. So yeah, we just want the images directory, back to PyCharm, over to new split engine, into the virtual environment, paste. the content of the images, and then, if I were to run it, no module named NumPy. Excellent. So now, it's been so long since I've actually fucked with Python, I forget. Is it settings? And plugins? It's not plugins. Build execution development seems familiar. No. Is it project? Project structure? Project interpreter? Project interpreter. Alright, so we need NumPy. Or Numpy, if you like. Install that package. We're going to want MSS as well. So install MSS. We're going to want OpenCV. Do you actually install it like that? Or do you just go OpenCV? Yeah. I think it's OpenCV. But there's OpenCV Python down there, a package to prevent exploit, OpenCV Python, wrapper package for OpenCV Python bindings. That doesn't seem right either. Christ, what's the package name? Python, package, OpenCV. OpenCV-Python? Pre-built OpenCV packages for Python. Is that... Do you guys say on your website for Python specifically? Releases, maybe? No, I just need the fucking library name and I need to know which one it is. How do I install OpenCV using pip? OpenCV-Python. Okay, it is that one. So it's you, install you. Those should be the three we need. And no others, for a minute anyway. And you've got them all. Thank you, thank you. And now, run it again. Yes. She's a-workin'. And she's a-workin' at 500 frames per second. So who was it earlier? What was the, being able to test something, multiple iterations? I know I'll have to import that from the standard library, but what was it? Because I will do that. That would be a fun little, thing to test here. So I will wait for your response, but it'll also be Python, let's test, time it? Time it. Alright, so if I just import time it. Okay. Now, how the fuck do you use time it? Time it dot. Time it dot time it? I don't know, I'll have to actually look this up, won't I? Time it. Python. Measure execution of small code snippets. Basic examples. Time it, and then you put everything in there. Class time it dot timer. Alright, let's try something more with the word example in it. Time it in Python with examples. Thank you. So my code equals whatever, what? Import time it, binary search, linear search, blah 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 blah. I'm just looking for where you actually use time it in here. Oh god. I hate people who don't like write fucking, you know? So here, time it dot time, it's like an example. Fucking get to the point, make it simple. What is all this shit? Why do you have to show off your binary search, linear search, this, that, and the other thing? Is this important to the usage of time it? Of course not. Fucking know what you're doing and then do it. Setup equals my setup, STMT equals my code, number equals 10,000. Number equals? You know, and why is all this in like this? I would highly recommend just reading the Python library reference manual for info on how to use time it. It's looking like a fucking thing where I can more easily wrap code around my own thing in a loop. You know, if it's gonna be like create an object and then load the object in to time it. That's not how it's written right now. Time it, Python, fucking, you know, manual. Docs, Python, library, time it. If I have to read this, then it's not useful to me. Time it, current text, setup equals text equals sample string, character equals G. You know, like, if it were something where I could do, like, time it and then fucking just put it all on the inside, then hey, there's a useful thing. Right? Boom. We're going somewhere. We're doing a thing. I mean, it wouldn't look like that in Python code. But, you know, like, that's when I have to reformat and restructure my code in order to use your function in order to do something, I might as well just write this myself. We can start time there. I can put this all into a loop for, God, it's been so long since I've written in any code here. I don't remember how fucking for loops work in Python. How do you write a fucking for loop on? I don't know. For key and file reset, and then when you're doing a numbered thing, it's range. It's range, right? Yeah. So for range of for I in range. Thank you. For I in range. 1,000, sure. We'll do that. For I in range of 1,000, do these things. And then end equals time, and then that would be 1,000 iterations. So I just change this to 1,000. And would that get her done? OpenCV, line 30. Invalid number of channels in output image. Okay, because I'm making FG into FG. So I do need to go back to gray FG. Gray FG. And then do again. There you go. We did it 1,000 times. The approximate frame per second is 510, a far more accurate representation of how many frames per second we would get out of this thing. Easy as that. Time it. Fuck it. Do you have a fuck it one too? Just run it a couple of times here, see the differences. 500. I mean, we could jack it up. We could go to just do 5,000. 5,000 times watch us do this, and then we'll just divide by 5,000. Well, 5,000 divided by whatever the fuck else that number is. I don't even know why these things are working, really. If I'm ready, hands off. We've been running it for a couple of minutes. Eventually, it comes back. I did it 5,000 times. I averaged a frames per second rate of 490. So there. Let's keep it at 500. In fact, so it'll run quick whenever we do that. And that would be, where was I doing that? Down here. Take the 0 off of that. So now we're getting more accurate results. But it's going to, you know, be variable. It's going to move around a little bit because we're live streaming. We got other CPU polls and things like that. But yeah, so it's around 500 frames per second that we're getting out of it as it stands right now. We want to, in defensive time, it is part of the standard library, and the manual does actually start with basic examples. Is it something I can wrap around as easily as making a for loop? Because it didn't look like that. It looked like it's, you know, time it and then give me a reference to the function that you want me to call, so I would have to take my code and then wrap my code into a function first, and then here's the function that I want you to loop for a bunch, and then report the value out, and it's like, what problem does that solve when I can just put it in a for loop and do this? Like, this is the same amount of effort and code, and I don't have to learn some other fucking method. What problem is it solving? Does programming fill you with anxiety, or is that just me, says Death? Fills me with anger. But everything does that. Yeah, we would want to get this, like, pulling in screenshots. That would be interesting. So, we get MSS working again. Find screenshot area with MSS as SCT. Return numpy array SCT grab area. Alright, so I believe the area that it wants is in the form of a bounding box. I don't remember the formatting of that exactly. So that's why we've got U open. And we can, I think, look at screen monitoring. Screen test is screenshot is that same bit of code, basically. Shot equals numpy array, SCT grab area, shot equals CVD color, and then I'm immediately taking it to grayscale through this. So this was just built for grayscale and nothing else. Okay. Return shot. So then where I'm calling screenshot of cap area is equal to cap area, which is being handed in from elsewhere. Self.screen is equal to screenshot self.cap area. No other calls to that, which means to see the usage, I would have to back out to screen test and stuff. You know where it's probably going to be, though, is in one of my configs, and this is one of them. It looks like it's being assembled from there as well. I'm sure if I just experiment with it, I can get to it. But so what do we want to do then, Pawn? Instead of doing background against foreground, if we do that out, and we say foreground is equal to, and we want to do a screenshot of the area, and the area will be something like, is it in one of those? Is it in one of these? 0. I don't know which would come first. 20, probably 1080, 1920, starting at pixel 00. Like that. And it's those two values. You know what I probably just np.bbox? Bbox? cv2.bbox? I remember, like, you know, there was documentation on what it wanted. mss.mss. No. Fuck. It's the little things, isn't it? So back over to here, and we want to do a screenshot? No, you don't call for screenshot. You would call for screen test, and you would hand in the data. So file.startScreen, file.standby patterns. Yeah, you're handing a lot of information in there through the start screen. Is that actually then at the bottom of this file, or maybe at the top of this file, where I'm defining this shit? If I look at config handler, no, where was I? Screenshot areas, runtime. And then I split those on the commas. I put it into a dictionary, which is why I was trying to do that. Yeah. Okay, I'm getting, closer, I guess. G equals screenshot. It just wants the area. 751. No. Let's just look up MSS usage. It's a lot of... Here we go. Oh, that's it. It's the fucking curly brackets. You silly pawn. And top left, and those all need to be defined as names, and yeah. It's just, it's a lot to fucking remember what the fuck things were. So, curly brackets for a dictionary. And then also, you guys need to be actual names, and not, what would be interpreted by the compiler as variables. Okay, so we do that screenshot, and then we should have something to work with. MSS is not defined. Where? Ah, well, because I have commented it out. NumPy is not defined. NumPy is NP. Did I use the word NumPy? Ah, NP. Okay. So, similarity, 33.750, but what? Does that seem quite right to you? Oh, well, you've got two entirely different things you're doing here. You want top and left to be 00. And then you want the width to be 1920 and the height to be 1080. Derp. Yeah, we should basically see, that's what I was expecting, was to see kind of an outline of the screen we're looking at laid over this, finding the differences, expressing the differences. So these two images are now 39% different than one another, and it did that 500 times, by the way. And it did it at still 490 frames per second. So the process of taking screenshots, 500 screenshots, did not significantly slow down this process. That's why I ended up going with MSS. It's still averaging around 500 frames per second when you're grabbing those screenshots. So, we're now dragging in a foreground screenshot. We need to be comparing against, what would be easier probably to compare against would be red test, or at least easier to see the difference. Because that's this, and then here's our here's our screen. It's just that circle. It's just that circle. And that's a 26.48% difference. Cool! Alright, so we're grabbing screenshots again. We're pumping those in. Like, there's not a lot. That's what's, getting me into a place from, where do I go from here? Because it is so fucking simple. And I got so much code in the old program that does so much crazy, complicated shit. It's not just, swapping out, the core engine. It's a lot of ripping out wires and what else would I do here? Before I got into the ripping out wires thing, if I were going to do that, because that's probably not the kind of thing anybody wants to see on a live stream, start ripping out the wires. If I went over to Clustertruck Splitter, didn't I have a collection of... Ooh, I deleted them all. Oh, I'm smarty every day. There's all my user interface stuff. Yeah, what we need basically is screenshots of the level complete screen. So, Let's go to level 1-1. The deal would be, okay, get ready. Okay, so did I just grab? No. You just go away. Did I just grab a screenshot? Let me GIMP, because we're probably gonna need it. We're probably gonna need it for some stuff. So put this in. Yeah, there's all my screens. I got 3 of them going on right now. So what we really need is just the 1920 by 1080 area. So fixed, not aspect ratio, but fixed size at 920 by 1080. And then I'll position you there. Get you lined up with here. And image, crop to selection. And there we go. We got ourselves a screenshot of the level complete screen. And we're already seeing like the speed bonus in there. I think that'll be fine, especially for now. The time being what it is and it having, fuck it. Fuck it. So we would export this to yeah, to there. To PyCharm projects. New SplitRP engine. Venv images. So that's where I would like you to go presently. And then we will call this LC1, level complete screen. And PNG is apparently what we're looking for. Oh, let me tell you what I want then. I'll tell you what I want, what I really, really want. So tell me what you want, what you really want. LC1.png, now we have that to compare against, so I can swap this out to LC1.png. And then we should, yep, see a very Clustertrucky kind of a thing going on there. Meow. Are you meow? Are you sure about meow? I'm surprised the image similarity is reporting so high, 69.3%. Just because it's computery kind of stuff. PyCharm for the win. This is Schrumpfmuff. 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 Yes, that's what I'm going to go for. So yeah, those are the two. There's the comparison. We're drawing in LC1.png. Screenshot could be live. And what if we didn't do any show image? What if we just put this into a continuous loop? And then we could see, like, percent changes. You know? Just tune in. What's the idea here? Recognize split frames with OpenCV similarity. Maybe. Kind of that. Yeah, well, we're using, we're using OpenCV in order to do a comparison between, you know, a file and what's on screen currently, just to, get a percentage difference. And, yeah, split frames, you're fucking dead on. And what I'm doing right now is just playing with, like, a whole new, very simple method to go into the program that I built quite a while ago, earlier in the year. Hello, Mr. Bags. You see him there? Yeah. What? What do you want? Hungry? No. I mean, not enough. He would have jumped on me if he was really... He would have been like, you're not hungry enough. Sorry. You're never going to get anywhere in this business. You're going to get hungry. He knows I'm talking about food, though, so he's like, are you going to actually fucking feed me? You're just fucking with me. No, I'm not. Not right now. You're not. You got more with the wanting it. Yeah, so how would we do that? How would we put ourselves into a loop where we could actually sort of monitor the output of the current percentage match? If I want to do it that way, I'd have to, like, generate a window. I could just spam it to the console for now, you know? Just keep going and going and going. That wouldn't be horrible and ugly, right? Yeah, I know. You winking at me? Just one eye? So, if I ran that like that, it doesn't pop anything up, but we get the comparative value. Okay, so what I would need to do then is get rid of this for loop. We're not going to use it anymore. And do we still run? Yes, but we do have to adjust our frames per second. Yep, still works fine. Any idea how you're going to sync the screen buffer sampling to the game frame rate? No, actually I don't. I started dealing with stuff like that in the later end of development on the Autosplitter when I was working on it. But at this point, nope. You know, it'd be nice to be able to lock it to the frame rate that's being played back or to the screen's frame rate, and this does only have to be a Windows application, so could, you know, grab some stuff through Windows C extension, you know, those libraries and stuff, so could do something like that, but it's too forward thinking for me, playing with the basics right here. Approximate frame per second, int 1. So we don't really want to even fuck with the frame rate or be bothered with the FPS for now. And you know, just print the similar percent. Alright, do the F print. I'll do, U. Nope. With a percent sign in there. I like the printf thing that they came up with. It's very easy once you understand it to just do whatever without having to think about it. So we'll at least have a percent rate that would be printed out to the console constantly. And then we'd put it in an endless loop. I mean, unless that actually freezes up my computer or something, then we should be fine for that. Yeah, fuck it. F strings were the best thing happening to Python in recent years. I really like it. Yeah, it's just very straightforward and simple and pack things in and boom, 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 and it looks right and it makes sense. A lot more than the other options that were available. Chris Benjamin with the sub. Thank you very much, Chris. So we don't need that for the time thing. I know, you're so fucking persistent, aren't you? Alright, we'll take a live stream break soon, and then I'll put food in your... I swear, didn't I just feed you? Are you just lonely? You've got a brother to play with, you know? So, you know... Wow. True. While true is true. We'll do this. Don't need the end. And yeah, gonna move you right up to there. So that should just do that over and over and over again. And gray FG, so FG is the screenshot, gray FG is, we're then grayscaling it, and then we're resizing it, and then we're subtracting that against the background that we're comparing against, and then we get the similarity percent being outputted, and if I press go, it just does it. And it keeps on doing it. If I were to bring something else up on screen, shouldn't that change it then? No, because we're not taking the screenshot. We need to take the screenshot every time. And I don't think we're doing that. What? You want to reload it? I don't even want to talk to you. I don't even want to talk to you, bro. Don't talk to me. The hand. So we're not taking the screenshot, which is why it wouldn't have impacted our, you know, actual time. Ooh, that was when we were testing how long it takes to do this thing. Well, too late now. Well, true. FG equals screenshot. Yeah, so you got to keep taking the screenshot. And then, yep, it's changing constantly. Its own output is changing itself as it goes. So then the only thing that would need done here for this to be like actually useful kind of a thing so that we could watch it, you could watch it with me, would be if I were to add a window capture for PyCharm. And then I just made this small enough so we could have it somewhere here. Put it behind me, over my shoulder, under my shoulder. Yeah, there you go. Now we can watch that, even as I drag it off screen. And now everything has become static, so it's gone to a static comparison value. So here's what we do now, friends. Did you stop running because I minimized you? Certainly looks like it. Yeah, so it can't minimize you. What we're going to do, friends, is we're going to get into Clustertruck, 29%, and we're going to play. We're going to play, and we're going to watch those values when I cross the level, when I enter the level complete screen. Okay? See if those spike. Yeah, that spiked pretty good. Oh, but then that came on, dropped it down to as low as 72% by the time that came up. Now we're back up to 78%. So that's going to be a thing. When we come out, we're back down to 20, 30-some% rates. Oh, this is so fucking cool. Isn't it cool when you write code that fucking works? And then boom, straight into there, and we're up to a 90% value. It stays high until the leaderboards come sliding on, and then we drop down to as low as 70-some%. So that could be an issue, you know, for our splitter. Because right now what we're seeing is that while we're in game, we get a standard percentage likeness of, I just saw 40, so that was the highest, and then we immediately spike up to like 93, and then as things keep moving around, we're in those, you know, high 80s, low 90s, but then when this happens, it's down to 77. So I guess our secondary value for comparison would have to be, you know, down there. It'd have to be, I don't know, as long as it's still above 60%, then we assume we're still on the level complete screen. I mean, it could all work. It could all work. There you go. It spiked up to 90, held there. We move on to the level. It jumps straight down to 33%. Let's try and, like, I'm starting to get some higher values. There, I saw a 77 in there, so it's nothing like a 90. Okay. Shall we stop this? And then what if I changed this to a lower resolution? What if I lowered it? We're doing 90 by 160. That's incredible. That is a very high resolution to be doing this. Didn't realize you already had the screen grabbing down. Yeah. As long as it isn't the pile of utter flaming garbage that is PyScrees, you should be fine. What's PyScrees? How effing cool would it be to OCR the time and the score on the level complete screen? You know what my very first attempt at doing this was? Was OCR the time on the level complete screen. There are problems with that. I actually trained my own fucking OCR, my own character recognition system that I wrote using Google's character recognition. I trained it on the glyphs. There are dead ends to that method. Like, even if you got the OCR working, the way that the game functions, sometimes that's not going to be helpful. But that is actually where I started. So what are we going to drop this to? 9 times 2. Let's get really fucking low with it. Let's go to 18 and 16 times 2. 18 by 32. Incredibly low resolution now. Start this up. And get back into Clustertruck. And now at this lower resolution, we're at sub 70 on this. Get into the level. Look up. Seeing some 41s. Look down. See some 50s and stuff like that, okay. Let's keep running. When we load in, we only jump up to like an 80-something. So we want more comparison, more resolution than that. Okay. Bring us back over. Just playing to see if there's like a butter zone. What do you want? Oh, I know. Let's do 45 and 80. Yeah, 9 times 5, 45, 16 times 5, 80. We'll get that running. OCR is way too slow to do the detection based on it. That's why I wrote my own, like, thing. And it was a very, like, it was quick. It was quick enough to be able to do it. Especially because it only needs to do it once accurately. Like, you couldn't do the timing live, but it only needs to, like, see the timer once you've hit the level complete screen and go, oh, there you go, there's the time. But there's a whole bunch of dead ends with that, because if you die in the level, then it would need to, like, know the amount of time that you were in the level before you died, and then add that time to the time when you finally end, and then there are levels at the end of the game where the timer doesn't stop, and it just fades out, depending. It could stop. There's dead ends to the idea, but it was totally doable. I mean, I did it. It doesn't work for Clustertruck. PyScrees is the thing that PyAutoGUI uses. And on Linux, it defers to using a program called Scrot. Okay, so there's a screes and there's a scrotum to take the screenshot, except it puts a temporary image in a PNG file, so you've got the overhead of making a PNG file on top of taking the screenshot inefficiently. Yeah, MSS is what I've, found after looking for a good, fast screenshot grabber. Okay, so we're here, and at this rate, I mouse over things, I make some gray areas, I get down into the 60s, but we're hanging out at 71. We'll run this screen, we get back into the game. That's a 73% match just being on the pause screen. Which is weird, actually, because this is very gray, and the level complete screen is completely fucking white. We could also thresh some of these values deeper down to black and white if we needed to, but I'm pretty happy with what's going on here. Would like to know the frame rate. Maybe I should put that back in. Just head over here and hit a level complete screen so that you can watch it as you're going through it. Bounced straight up to 88% or something like that, so... at this point, while you're in gameplay based on this, I think our best thing was with the higher values, with the higher resolution. So we were up at 90 by 160. If we went up again from that in a double increment, we'd be looking at 180 by 320. I just don't know about the frame rate at these levels. Who's to say that I'm unhappy because I rarely smile. But that'll be a much, more... It's a close image. It's looking at a lot. Look, we've got an 82% match, even on this screen, and this has this thing in the middle of it. I go over here, down to 81. Okay. Let's go into another level. You know what? Let's go to an easier level that clears quicker. And I'm trying, really, to watch the numbers as opposed to the game, so... Just stand here, watch the numbers. I saw 40-something come through, and then boom, immediately up to 95, 94 at this level. We need to know the frames. We definitely need to know the frames then, at this point. So I'm going to pull this over. Sample that segment at high res. Then again, you're not going to want to specify a region for each game manually. Huh. I'm already considering that kind of stuff in terms of, having it in the config file that you could specify specific regions, and that's actually how it was already being done in the old version, to be a completely different method, so I'm open to that. I think that's easy to support. And then it's just down to the config file, it's down to somebody writing a config file for the game that they speedrun. You are up my ass, aren't you? I scared him. I kind of meant to scare him, but I didn't mean to scare him. Unless the house is on fire. Or someone's in here. In which case, that's not good for them, because I'm going to fuck them up. Printf similar percent. So we want to add to this printf the frames per second. So... we just do start time, and it's going to slow down the frames per second that we're printing to the console. You guys told me that, so I will bear that in mind. So we just use the start time. We do similar percent, And then I will do this and do FPS running at, and then what's our formula going to be for the frames per second? Well, we've already got one down here, which was time.time minus start. Oh, I never changed that either. That's supposed to be end. Okay, but I mean, that's good for our purposes. This is exactly what we want right now. So I'll grab that, put you up here. So, do I need another parenthesis? Yep. But down here, we don't want time.time. We want end. Which actually means that our frame rate was probably higher, well, but we didn't have the screenshot being taken. Whatever. That should print it out now for us. Yeah, well, okay, so it might be wrong. It's because we're not reloading start, which is what we need to do. Time.time minus start, and then the start equals time.time. Let's just put that at the top of the while true statement. Okay, so that's pretty slow. Again, it is, you know, pumping out to the console every fucking thing. If we didn't, I'd need an exit. Like, I'd need to then be monitoring the keys so that I could, like, escape out of the program so that it would recognize that it's the end, and then it would print the final value, and I don't want to have to do any of that shit. Let's get into the game again. So yeah, it's gonna be hard to, like, how would I do that? We're doing 20 frames per second right now with the print. I like that this works. OBS capture is too small to show frames per second. Oh, it is, isn't it? There we go. And I can move that up a bit too. Sorry. MSS has the same flaw of saving a PNG, although you can also bypass saving the image and you get a better frame rate, I think. Well, if it's saving to a PNG, I mean, when I wasn't doing this, we were getting fucking 500 frames per second while doing calculations. I was getting 1,000 frames per second. Whatever it's doing, I have tested multiple, Python screenshot libraries, and MSS was the fastest one that I stumbled upon. However, I have been recommended today D3D shot as a potential fast one too. Yeah. So I have written in the past, like timing.py, I made a frames per second timer class. So if I were to do this, by the way, do you use either of these as class, need those functions? No. If I were to do that, then I would instantiate the frames per second timer, and then we could just call it once a second to update, or every 5 seconds or something, right? We could ask it what's going on. I don't remember how I built this thing, so I'll have to actually look at it. So when it resets, it gets time.time, and it sets its frame count to 0. And then when it updates, it does frame count plus equals 1, so I need to send it an update notice. And then If time.time is greater than self began plus self.interval, then self.frame per second equals self.frame count divided by time, and then self.reset. Huh? Let's just trust the class, because I don't know off the top of my head. And then we would instantiate it. So I need a new frames per second timer. So FPS is equal to FPS timer. Don't need to give it anything in, right? No, it's fine. It'll do the interval on its own, I think. But if we've got the FPS timer, then we wouldn't need to do the start time thing. Would reset right before we go in, so that'd be fine. And then you know what we would need? This is kind of like redundant to have the class now. So we would do start equals time.time. And then the idea would be like at the beginning of each loop, if start minus time.time is greater than, and I don't know, is it going to be, what's the standard here going to be? Is it milliseconds? So if it's greater than 1,000, if start minus time.time is greater than 1,000, then print that, and start is equal to time.time. In which case I don't need the class of frames per second timer. And then it'll just, once a second, it will give us what it's doing. Is the idea. FPS timer is not in use, you're right. Okay, so time.time, let's just try 1. Okay, let's print start minus time.time and see what I'm doing wrong. Okay, so we're a negative value because I'm doing start minus time.time. I should be doing time.time minus start. Yeah. Okay. Simple as that. Yep, there we go. The frames per second is for shit. It's not telling us anything right now. So why not? Frames per second is 0. Because we need to count how many frames we've actually gone through. Happy belated New Year's, Pawn. Gonna be a good one, I bet. Thank you, Jim. I hope you had a good New Year's, celebration. I just stayed on the couch. So we need to count how many, frames we've done. Frames. How many calcs we've done. We'll call them calcs. Calcs equals plus equal to 1. Does that work in Python? I don't think that works in Python, does it? Then you have to do calcs is equal to, we'll whatever. So calcs equal to 0, and then start equals time.time, calcs equals 0, and then it would be the integer of calcs divided, right? Start you up. Wow, it was actually being kind of accurate in how many frames it's taking to do this this stuff. Plus equals does works in Python. That's not what you said, but that's what I said, King of Britons. Thank you. Slept through the whole effing thing, to be honest. New Year's? I couldn't sleep because they were shooting. So this was actually not inaccurate. That being the case, our current resolution then is, you know, a bit insane. If we dropped it down back to half of this, 90... Wait, what were you at? You're at 180. Yeah, okay, so I'm doing times 10, so 90 by 160. Still 20 frames per second. Oof. Go down to 45 by 80. Still 20 frames per second. Oh. Why you be all with the taking so long in the doing of? Or maybe my frames per second calculation is incorrect, because I didn't really think about it. I just sort of copy-pasted what I had before. They're setting off fireworks by the hundreds here. I got in a fist fight. I really did. My arm still hurts. Really? That's way more interesting than slept through the whole effing thing. Are you playing, or should I believe you? Go all the way down to 9 by 16. Now, we noted that really it didn't make that big of a difference. 45 by 80, right? No. We noted that it really didn't make that big of a difference, changing our resolution. Is there something that we're doing that would slow this deal down? Start is greater than 1. Print similar percent, whatever the current similarity percent is, and the frames per second, which is calculated by the integer of the number of calculations we've done, divided by time.time minus start, should be, you know, the amount of time, the number of things we've done, divided by the amount of time. That seems right to me. Shoot. I wonder if the screenshot is the thing that's taking, you know, the piss here. So if I tab out the screenshot and I put this back into just read streamer.png, we're immediately up to 420 frames per second. It's the screenshot, and it's the size of the screenshot. Grabbing the whole area. Grabbing the whole 1080p area is apparently killing MSS. Shit. I had so much love for it when it was working for me and what I was doing, but I was using smaller areas. So yeah, it is. It's MSS, the library for grabbing screenshots. It doesn't want to operate at 1080p, and it's slowing us down to 20 frames per second as it's doing it. Damn. I joined late. What does the screenshot thing do? Damn it, you just got to that. So yeah, it's watching us right now. If we go into Clustertruck, you'll see the things continue over here, and we're on a level complete screen right now, so we should have pretty fucking similar... Hang on, if I go to here, and then I go here... okay. So now we're down to a 20-some% match. It's looking at the screen and it's trying to match it for the level complete screen. I look in a bunch of different places. There's a 50. But then we get here and boom, we're up to 88s, 87s, 90s. So it's working. But right now it's working too fucking slow, and the hang up is MSS having to grab the whole 1920 by 1080 area. So we can easily reduce that area in order to help MSS work. But I was just recommended D3D shot at the beginning of this live stream as an alternate Python module. D3D shot, pure Python implementation of the Windows Desktop Duplication API, leverages DirectX, Direct3D, to enable extremely fast and robust screen capture functionality for your Python scripts and applications on Windows. Fastest way to capture the screen with Python on Windows 8.1 and over. Some people run Windows 7. Screenshot to memory. Import d3d shot. D equals d3d shot.create. d.screenshot. If you've got multiple screens, though, it's an image, RGB as opposed to BGR, 2560 by 1440. Screenshot to disk, screenshot to disk. Screen capture for 5 seconds and grab the latest frame. So create the decapture time.sleep. Capture is non-blocking. So we wait explicitly. Screen capture for 5 seconds? Okay, so it's actually creates a movie. I mean, it saves all those images to memory. Screen capture the second monitor as NumPy arrays for 3 seconds and grab the 4 latest frames as a stack. Screen capture the second monitor. So create capture output equals NumPy. Okay. D.display equals D.displays1. So we're instantiating an object capable of taking the screenshot, and then we're setting that object's display property to the second monitor, which would be 1, because we're programmers and we count from 0 up. And then we would do the capture, or the screenshot if we just wanted a screenshot. It looks simple enough to implement. My immediate concern, though, is where it says this works on Windows 8.1 and better. I know Windows 7 is being, like, deprecated, or has been already or something, but, you know, people still using it. I wouldn't want to build off of a system that, you know, won't support Windows 7, at least not for the next year or two. At this point, I am thinking more. I am more thinking. I are more with the thinking, Joe. What are you? You're the Clustertruck expert? Fuck off. I'm thinking that we reduce the screenshot area and take a specific area of our of this that we created. So if I were just looking for, like, the word complete, and I gave it a good wide berth, much as I can give it. Oh yeah, unfix me, because we know that it shakes around. If I were just, like, looking for that, it's unfortunate that due to 1-to-1 and 1-to-10 being different widths, you can't check for very exact area. Windows 7 no longer receives support. That just kicked in, right? I definitely heard that it was a thing that was happening. So if I were like that, I'm just, you know, interested in grabbing the biggest area that I can of this sort of screenshot without necessarily grabbing, like, the grays and whatnot. That's fine. So that is, I only did that because I want the values that you can't see right now because they're underneath this. Which are 887, 119, size of that kind of thing. So, get you back up? No, get you back up. Alright, so how do I do this? Oh, you're still hungry. When I load in the background, I want BG equal to... Is it just a thing that I can do with, you know, array declarations? God, it's been a minute. So that would be like BG from position 887, or rather we'd be going vertically first. So we'd go 119 to 119 plus 184, which is, you know, thing for a calculator. 19 plus 184, 303. So it'd be from 119 to 303, and from 887 to 1713. I don't think that's how you do that. I think you do it with a bounding box, right? I'm gonna end up with something really weird there, is what I believe is going to happen. And this will probably break it, because we'll be in weird processing mode. You know what I want you to do then? Show image BG. Shit! I'm awesome. I didn't think that would be correct, but that's correct. Alright, fucking excellent. Cool then. So you stop being a thing that's going on. So actually then what we want to do is, you know, declare variables. Let's say the area, the area, is going to be equal to our, be equal to 119, 887, and then, yeah, fuck it. You know what? Don't get tricky. Just hammer it in right now with hard code, and we'll see later. Because I can think of 17 different ways to do that. So that. And then when we take our screenshot, we want the top to be 119, the left to be 887, bits for pause, bags, and hacker pawn. Thank you, Mosaic Task Force. Suddenly night vision. Oh god, I'm blue. Dabu dee dabu die, dabu dee dabu die, dabu dee dabu die. I hacked too hard. I fucked up the whole RGB spectrum. It's a problem with your monitor. I think I fixed it though. Did I fix it? Is it working now on your end? Thank you for the bits, Mosaic Task Force. So top would be 119, left would be 887. We want the width. Shit. See, that's what. So I should have done. So the width would be your mother 826. And the height would be 184, and that'll be the size of that screenshot that we take. And now, we're doing 60 frames per second. I think I'm going to want a better library than this. But we are up to 60 frames per second. And the thing is that with the speed of the calculations being at like 400, we were getting 400 of them per second, 500 of them per second. Like we can do many calculations in between each frame tick without it actually having much impact or any impact on the frame tick. Because the slowest thing going on here is the actual screenshot. So we can take that screenshot, it takes a minute, got it. And then we can go check, and take another screenshot, and it probably won't even notice that it's happening, but it's working right now. Our resolution is now fucking weird, I would say. Let's do resolution of exactly what it is. 826 by 184. Should be the height and width of the thing. Okay. So that should be, you know, it's still trying to resize it, so that takes time technically, but we're probably not seeing any of that because the screenshot is the thing. But yeah, now it should have a higher level of being able to determine when we're looking at something that matches it when we're not. So this matches 85% right now. We replay the level. We're at 29, 30%. Good. 5s, 15s, 20. Oh, shit. Hold on. Just get to the goddamn level complete screen. That's all you gotta do. Just up to here, stand here. Just watch. 34, 32, 93%. And it's sticking hard at 93 until that box slides on. And then we're down to 86. These are very consistent figures, you know? Very consistent figures. And a good thing about MSS is it does not grab the mouse from on the capture. It doesn't see it, so that doesn't change our percentage at all. That's a very consistent. Let's go to another level and see if we get the same 92-86 kind of deal here. Okay. 88.5. It's in a slightly different position, slightly different size, and then 84, 81. Okay. Level 1 complete has a different width than level 110 complete. Will it work on level 10? Good question. I mean, it has a different width than 1-2 complete, too, because 1 is a small thing, and I don't think they're using fonts that are this unispace font here. Like that 1-2 pushes it out a little bit as well, which is why we're getting a lower figure, which is also why my original code started with a edge detection system in order to figure out where it should be taking the screenshot, and then it took the screenshot there, and then it was able to like have some faith in like the confidence and things. You know, a lot more confidence factors. Alright, 110. 110, he asked about. Let's try that. $87, holding 87, and then 84 when that slides in because it's seeing some of that gray. So we could actually make it tighter so that it doesn't see that gray. And then that would give us more confidence. It would still be a little bit off because of the thing going on there. This is also at the original resolution. It might actually behoove us to like half the original resolution of this image, which is 826 by 184. So just give me the calculator again. I don't want to have to fucking think. 826 divided by 2. Alright, 413. Wow, that's really easy. Why? Easy math. 184, that's less easy math. 184 divided by 2 is 92. That's actually really easy too, once you see it done. So if we half it, then we'll have like less fine, like it'll be muddled, and that might actually help us a bit in getting more consistent output. So I'm going to start her back up. 59%. Get into Clustertruck, we're up to 73. We get in here, we're seeing 80%. Alright, so what if I went even lower now? So 413 won't have. That dog won't have Monsignor. So if we just do 206 and half of 92 being 46. I'm convoluting it. I'm making it blurrier, basically, by shrinking that. That's what's happening, you know, on its level. And then here, it's now down to a 78. So here's my question. Whoa! Okay, pay attention to it. My question is, do we come through the level complete screen with a more confident match originally, though? No. Now, it seems to be a better comparison just at its natural resolution. So, if I bring you back over, let me go back up to whatever it was originally, yeah, seems to be that. And just for the sake of it, just for the fun of it, let's do a show image on both of the things so that it's clear what the fuck we've been doing here. Show image, BG, show image, FG. We do have an FG read in? Yes, we do. But you're doing FG CV2 IM read. I don't want that. I want, yeah, you know what? Put both of those back, and we'll just copy this screenshot code and put that up here. I will just... Oh. What? Yeah, okay. What the fuck ever. So we'll start it up. That's what we've got in file, and that's what we're comparing to that right now. Because that's the first frame that we were up. And it's saying that those two compared are about 74% the same. Hey, it knows its business. Don't talk to it about its business. They looked a lot different to me, but what do I know? What do I know? Actually, this would be better, too, if we could... I mean, fuck it. Let's shove these into the stream, which will just... It's going to break this entirely, but let's shove them in here so that we can see what they are after the processing, just to see what we were working with to get the numbers that we got. So there's you, and it was versus you, and 74.591. Wow, those are so friggin' different, though. I guess it's because there's similarly wide open plane, or... It's also because they're being grayscaled. If I were considering the color values, we don't need them, though. We do not need them, is the important part there. Harder for debugging, but might be more efficient. What? Quick question, is there any spot in the game where there's just pure white, like the other areas of the complete screen? Couldn't you just match the white areas? I think you can just sort of look up at the sky on certain levels, or just stare down at the trucks, and that's why I was looking down and looking up. Didn't really work on desert, because desert's got a nice blue sky. But that's a concern of mine, that we do need, you know, enough difference going on there. We need to be testing against letters. We need to be testing against something that's got form and shit to it. Sadly, lasers are white on low graphics settings, as I recall. Oh yeah, that too. That too, huh? But the numbers that we are getting, the figures that we were getting, like when we were taking the full screenshot, which I liked. You know, we were getting good high figures, and like once we're in game, oh shit. Once we're in game, no, I don't want to take that stuff out. Once we're in game, we're getting pretty consistent with like below 50 matches. So if I move you over here, in game, when we're running the game, from any one of the screens here, actually, let's go back to there and pause. 77% match on the pause screen. And we're now looking for like this area and for the word complete, and the word complete doesn't have enough like stuff going on in it. So the fact that it's like flat means that there's not a huge difference between the white and the, you know, what will translate to a light gray or a medium gray. But once we hit here, boom, 93. And then down to 85, and we were seeing high 80s at the worst when we were hitting level 1 complete. So there's definitely some tweaking and some tinkering that needs to be done here, but I want to be able to screenshot the whole fucking thing. I would much prefer to be able, and the only thing that's slowing us down right now is the screenshot. All the operations that we do on a 1920 by 1080 screenshot are not an issue. It's the screenshot itself that is slowing us down. But that being the case, I am going to put it back to the slower version. And what's going to happen in future if we want to develop on this, is that I'm going to have to try the D3D shot, and if not that, then something else that that can do it at high speed. Because, yeah, this is only 20 frames per second, but we get into Clustertruck. Oh, my resolution is totally fucked, too. I forgot about the resolution, so change the resolution to fucking full resolution. Who cares? Do it at full resolution. See if it changes it at all in the frame rate. Nope. Full resolution. We get into the game. Match of 74. I come off of the screen. Match of 87. Go to the next level. As soon as we're in the game, down to 26s, 25s. Whoa! Okay. Goes from an 18 to a 96 match. That's just so good. That's just so good. You know, those are values that we can definitely play with and tweak and tinker with. There's a 97 to start, a 96, a 95, a 96. Once that comes on, then it drops down to a 77 because we've changed, you know, a lot here. But what you can do is set yourself up with it needs to drop below 50% before, you know, you'll release it. So as long as you've got an above 50% metric, a match, then you won't let go. It needs a, you know, 88% or higher, but it won't let go until it's a 50, and then as soon as it's below a 50, it assumes that we've left the next level screen and goes into the next waiting period for a next level screen. So it sees that 28, and it goes, oh, okay, that's what we'll do. I got you. Now we're running again. And then boom, we jump in here, 96, stop the timer, we're on a next level screen. Don't leave the timer just because we drop down to 77. It's higher than 50, or it's higher than 60, or whatever we end up setting it at. This is totally viable if we can just get a library that can watch, that can pull screenshots at full resolution fast enough. Now, I should also bear in mind that whatever, like, speed that I can get a full, you know, 1920 by 1080 screenshot out of whatever library I put together on my system, it's got to function on other people's systems, so, you know, with lower specs, and it's also, more importantly, got to function on, like, 4K resolution screens. If you're playing the game at 4K, eventually this Autosplitter has to support playing the game at those higher resolutions. So, you know, if I'm not taking an area and analyzing that area and looking specifically at, I want to see similar things going on here, if I am doing a whole screenshot observation, you know, I'm gonna have to have a very powerful library thing in there that is doing that. That is just grabbing those screenshots as fast as it can. Doot doot doot. Why don't you just read the process's memory and figure out when the level starts and ends that way, says Mike Boy 39. It's been tried. Good point. Just checked. Truck color is identical to complete screen color. It's very white. But yeah, we've got a very good, like, this works. This absolutely works. The only thing slowing us down right now is the actual grabbing of the screenshot. So we would have to try this D3D shot stuff. And maybe something else, you know? Maybe there's another something that does even better than this. Because, I mean, you know, recording screens. It's a thing. Let's do this. Let's get this D3D shot, and we'll see. So file, settings, over here, add, and let's see if you're here. D3D shot. Yep. Extremely fast and robust screen capture on Windows with the desktop duplication API. Install that package. Clustertruck, as far as I'm aware, is only distributed on, you know, it's not on Linux and Mac. Maybe it is, but I don't think so. I think it's on Xbox and Switch and PlayStation and PC. So D3D shot installed successfully. So we got that. We'll import D3D shot. And then let's look at the documentation again. So first we instantiate an image or an instance of this thing that we'll create it the same way that we're doing with screenshot here, except for we can just make it a d3d equals d3d shot dot create. What is it? Create, and then screenshot from monitor 1 is what we want to do. So that would be d3d dot screenshot, and it was just we have to set the display. That's what it was. So d3d dot displays dot display is equal to, and this is the list of the displays, and we want 0 for the first monitor. I wonder if I have to specify that. I might not have to specify that. Let's see if I don't have to specify that. D3D screenshot. So this stuff would come in down lower, but we can do the instantiation up there. Although, fuck it, let's put it all down. Get it out of the functions. So down here, declare variables, you do that. BG is equal to that. FG is equal to the screenshot function, which, no. We're going to make d3d.screenshot, and then how do we use that? d.screenshot, how do I access it? Is it d.out? So d3d.screenshot, fuck you, and then fg is equal to d3d.out. No. How do I use it? You're showing me how to capture it? You're showing me how to set displays? Get the last 4 frames as a stack. Frame stack equals d get frame stack. d.get latest frame. Is that what it's gonna be? fg equals d3d dot get latest frame. Okay. And then every time that we went to do one of these, we would do d3d dot screenshot. I wonder if I could just do fg is equal to d3d dot screenshot. Probably not, huh? And then fg is equal to, but that's fg, gray fg is equal to, yeah. That's fine. Alright, see what breaks. So, line 46 in module. It's color? No, it's not. AFG, CVG2, The error is assertion failed, source empty. D.get latest frame. Is it just the thing? Can I just access the thing and it will give me output without having to do anything? So d3d.screenshot, could I just say that f3 fg is equal to d3d.screenshot? No, because that doesn't return an image file format. What the fuck do you want from me then? Like, how can your examples not include the, oh, and this is how you use it part? Like, you're saying out one pill image, but, like, neat and everything, but how do you mean for me to access that output? Screenshot to memory, screenshot to disk, screen capture for 5 seconds and grab the latest frame, grab it as a stack. How do I just get access to the fucking shot that I just took? Still looking. Shouldn't have to fucking scroll this much, huh? Great tutorial. Apparently D3D screenshot should output the screenshot in the format specified in the creation of the D3D objects as laws. So then where it's down here saying my different like capture outputs. So then D3D create and then capture output equals numpy should be fine for me. D3D shot create capture output equals, was that in quotes? It was. NumPy. Seems to be working, and we gained 10 frames per second. Fuck. Let's just check that. Let's just check that we're getting what we expect to be getting. So if I were to show image on both of these things after processing, we were doing before, show image, actually just FG, because that's the only one that we're fucking with at this point. So FG. Yeah, we're getting the screenshot, and it's exactly the screenshot that we, anticipate it being. And I'm gonna have to stop that because that's getting him away. Okay, so that much more efficient method got us 10 frames. Cool. Where's the show image? Take the show image out. So let's try making our lives better with, 18 by 36. Just, cranking down the resolution. Maybe that's a thing. Maybe it's the processing that's slowing it down. It's not the processing that's slowing it down. It's the capture. It's still the capture. Shit. Just make sure you're doing this before you use it. Foreground is equal to d3d.screenshot. Taking the screenshot, and you're setting it to FG, and it's in the format of an numpy, and then you're converting that to a gray color space, and then you're resizing it, and then. Damn it. Damn it. It claims to be the fastest way to hook into something. And, DirectX hooking in. DirectX hooking like if OBS can do 60 frames per second for y'all right now, then this using the same methods, is it possible that just my frames per second counter is wrong? I keep thinking about that. Like, I'm taking the number of processes and dividing it by the amount of time, Actually, the way we're doing it right now. Couldn't I just say... Because it should be 1. It should always be 1. So my frames per second could literally just be calcs. Yeah, which more directly gives me confidence that it is doing this operation 30 times per second. Because we're measuring time.time minus start, and every second it ticks up. And so we've done it 30 times, so that is absolutely correct. Shit. Like, does it make any claims as to, like, how fast, how many fucking frames per second? How many captures per second to aim for? The effective capture rate will go under if the system can't keep up, but it will never go over this target. That's nice to have, but do you make any statements about how fast you should be able to do it? A 1080 on Intel UHD, you think you can grab 60 frames per second, do you? NumPy float, limited to 30. I wonder if we're doing NumPy float. I wonder if it's just being sort of, ratcheted in there. But it's looking like NumPy is the way to go, and that is the thing that I chose. And I'm running on a 1070, so I should be closer to a 1080 Ti here, and that's UHD graphics, that's 58, so it should be hanging around 58 frames per second. Let's test if it weren't doing anything other than grabbing the frames. So if you were just doing that, like none of that happens, none of that happens, none of that happens, and then the time and the thing, and then go. Similar percent is not defined. Alright, well then, but I need... Okay, so it actually is pulling out closer to 60 frames per second. But our processing is taking up half a second, which is ridiculous because when we don't have to wait for the screen capture, we just fucking tool away at hundreds of frames per second. Sometimes 1,000 calculations per second. Manipulations on something that's already resident in memory. Still, 60 frames per second is not good enough. You know? Even if that were... even if we could get it down, like, that's not good enough, 60 frames per second. I want more frames per second to work with than 60. Because I want to be able to do these calculations many times. I want to be able to analyze this against multiple images, do comparisons against multiple images to see, are we on the level complete screen? Are we on the pause screen? Are we on that screen? No, none of the above? Okay, do it again. Your processing on the CPU, OBS hopefully works, 100% GPU. I don't know actually how it grabs, but I know that the encoding is definitely happening on my CPU and not my GPU. GPU is slower, at lower quality. It might be using the GPU for calculations, though. That's actually a curious statement, because what are we consuming while this is running? 31%, and then I stop it. And we're down to 21%. Yeah, so it's 10% CPU, which is not insignificant, incidentally. It's not a small amount. So D3D is not like our be-all, end-all, oh, you saved us. And I would rather use a method that didn't state that it didn't work on things lower than Windows 8.1. So I'm pulling it back out because I would rather be using the other one and figure out, or just something else entirely different, potentially. So don't need the D3D screenshot, don't need any of that. Do need you back. You up to full res, why not? Especially since Clustertruck is on Mac OS 10 and Linux. Is it? Well, then they're fucked. Those people are fucked, because my program's not going to support that. Because I need access to certain Microsoft things in order to get my application to do some of the funner things that it does. So, BG equals color BGT. I'm just checking to, like, where else do we have references to the D3D shit? Because if if the other one is taking 20 frames per second and half of that is, you know, our processes going on, which it shouldn't be, and that's interesting. It makes me wonder if it's like the fucking file access or something. You know, that it has to pull it again, pull it again, pull it again, pull it again. If you just overwrite the current graphical data into the memory space of the last one, it just doesn't make any sense why we would be able to process, you know, data that we've got on hand at 500 frames per second, and then when we had to grab it and then put it there, that it would take, you know, enough time to eat half of our processing time. We were doing 60 frames per second. As soon as I do the processing again, we're down to 30 frames per second. So half of that time on something that was before just taking a few clock cycles, now it's taking a whole bunch. It sounds to me like it's waiting for the hand it off thing still, somehow. What else have we got in here that I would need? Nothing? Are we back to the old method now? And we're running at 148 frames per second. That can't be right. I mean... That's because we're not pulling in a screenshot, right? Is that what's going on here? Yeah, you're not pulling in a screenshot. So why is it even taking 100 and some? Well, because you're doing it 1920 by 1080. So let's go back to one of those, you know, reasonably ridiculously high numbers, like 45 by 80, and then do it. And we're seeing 420 blaze it frames per second at that rate. And then as soon as we add in the actual grabbing of the screenshot, the 420 frames turns into 20 frames. So I don't know how to explain that exactly. So you have the BG, and you got that for streamer.png. Don't worry about that. Screenshot area, yeah, I want to keep that around. I guess I want to keep that around in case I'm forced to go back to that in future. Okay. Let's just put all of our actually being used code together, though. What if? Okay. Though. And a You know, and because we're only doing a smaller capture area in SplitRP as it exists today, that runs at consistently over 60 frames per second. Right around 60 frames per second when it's doing all the calculations, when it's checking for level complete screen, and then checking for this, and then checking for that, and then it's got like several checks per cycle, depending on which state it's in, sometimes more, sometimes less, and it's consistent at 60 frames, more or less, with all that going on. This one, you know, it's just that we're grabbing the whole fucking screen that's slowing us down so much. Which is a damn shame, because, like, I would love to do the full fucking screen. You know, and if timing in Clustertruck weren't what it is, which is, like, down to the sometimes, I mean, it's been down to the 1,000th of a second with me breaking world records by a single frame and stuff, but down to the 100th of a second, I can't have my measurements, you know, even if I could keep them running at 30 frames per second. You're losing too much precision in that for a new Autosplitter. So yeah, our problem is Python screen capture. How do we get it? Python fastest screen capture. Yeah, you claim that. Take screenshots quickly from Python on Stack Overflow. Asked 10 years, 4 months ago. Who's got, like, there's one answer? Okay, that's gonna be, It's a little bit outdated. You might want to move that one off the top of the list there, Google search. Python MSS, that's what we were using. Ultra fast cross-platform. Let's see, fastest, like, fast, full resolution screen capture. I've seen all of these before. Pi screenshot module, cross-platform, useful for Linux-based distributions. If I go back to MSS, where's MSS? I'd like to see your claims about it. Ultrafast cross-platform using C-types. Grab one screenshot by monitor or a screenshot of all monitors and save it to a PNG file. But you can use PIL and benefit from all its formats. Integrate well with NumPy and OpenCOV. Embedded into games. Fast and platform optimized methods to grab screenshots like AI computer vision. I mean, I was impressed by this when I first started using it. Python MSS read the docs index. Thank you, Wilson. I've landed there myself, apparently. One shot per monitor for file name in sct.save. What? Oops, sorry. I just punched the microphone. How did that sound? For file name in screenshot.save, print file name. Screenshot of the monitor 1, file name equals screenshot.shot. Print file name. Don't know if this will be any good. What about this? Auto GUI? That was, someone was saying earlier that it's the same bullshit. And not as good as MSS even. Necessarily, I don't know. On a 1920 by 1080 screen, the screenshot function takes roughly 100 milliseconds. It's not fast, but it's not slow. What is that in a second? 100 milliseconds is, it's simple. There's 1,000 milliseconds in a second, and it takes 100 milliseconds, so you get 10 shots per second. They're not even claiming on 1080 that it does more than 10 frames per second. Am I reading that right? Yeah. 10 per second. Ugh. At least this one's doing 20 some. I'm curious also to know how fast it would go if I were asking it to do nothing, because the other one came up to 60 frames, a little bit under 60 frames. So what would this screenshot method do if there were no processing being asked? Oh god, I've had you running. If there were no processing being asked of us whatsoever. I gotta take you out. Empty expression not allowed. Well then go fuck yourself. It's still stuck at 21 frames per second? I wonder if this is just a limitation of Python. I wonder. What do you wonder? I wonder if the D3D that we were using wasn't doing 58 frames per second, a little bit around 60 frames per second, because it won't bother taking more frames than it's out if it's V-synced, basically. if it won't bother taking screenshots as fast as it can. And I'm running at 60 frames per second. You know, which with a little bit of overhead, minor, turns into 58, 59 frames per second on average. I wonder if the D3D is actually capable of being faster than it is, but it will only take a frame at the rate of, the monitor. What does Quargs do in Python? Quargs, God, it's object arguments, fuck. So, arguments, if you're going to pass them into an object or a function or something like that, usually a function of an object, would be, you've got an argument. So there's, input equals, and then you're sending it the input, when you call it, and so it ends up that input equals this. If I recall correctly, Quargs is the idea of being able to just sort of attach a bunch of, oh god, don't take I'd have to look it up again. I was using it when I was writing my library, but the idea, what I was going to say is the idea of being able to just pass, like, a bunch of various arguments to it, and then be able to sort of cherry pick them out of an array. So you don't need to define ahead of time that this is going to have this argument, this argument, this argument. Because, like, the way that you pass arguments along to a function is, pull open an example, since you wrote one of these things. So, let's look at, I'm looking for one of them that's got a nice init. Alright, so here, a childable window, when we initialize it, it needs to receive, when it gets initialized, its parent, and then if you give it a position, then it will, overwrite these values, but if not, that will be there. If you tell it, it's got instantiated qualities, so visible, false. The Quargs is that, like, other things can be passed along to it that are not these, and that don't have to be, like, in this order. At the end, you can just pass things along into it without them having to be position or visible. So there can be extra arguments attached. And that allowed me to, while I was writing this, I believe that allowed me to pass through, like, arguments that I wanted to go to the super, the instantiating object, the object that I'm building on, which apparently here is top level window. So if there were arguments that needed to go to top level window, slap those on, I'll take them all, I'll shove them to top level so that top level knows what to do at its level of processing. And then for me, I need the parent, the position, and the visible accessible. Yes, that's kind of, don't listen to me, basically, on that. It's been too long. Your math, I think, is saying that your frames per second is equal to time between time, right? Actually, what it's doing right now is just counting the number of processes that we get done in 1 second. So we're just keeping track of start, and then when time minus start is greater than 1, when there's 1 second, then we fire this routine and we just pass out how many calculations have been done. So each cycle we just iterate. And just add 1 to it. So it's a very simple thing there. We're still only getting 20 frames per second out of just taking the screenshot. I would love to see, like, their claims. Do they make any claims about how fast they've ever gotten this up to at 1080p? Because, I mean, if you're going to release something like this, that would be pretty straightforward things to, to immediately put forward and say, yeah, intensive use. Oh, this is a bad usage if you plan to integrate MSS inside your own modular software for in range 100. It's much better with MSS as SCT for in range 100 SCT shot. The thing to save MSS instance inside an attribute of your class and calling it when needed. I actually gave them some feedback on this too, that I believe they actually changed it based on it. I don't understand what they're trying to do here. With MSS as SCT for in range 100 SCT, I don't know what you're trying to do there, what you're trying to say. Installation is obvious. Like, do you have benchmarking? Okay, so you say if I go here and I type in FPS, benchmark. Okay, so they're suggesting that if I used multiprocessing, then I could get better performance out. So that there was just one thread, I presume one thread is what they're talking about, but I don't know, doing the PNG file creation. I've had trouble with multiprocessing in Python. Like, I can't seem to break out of when I've tried to, you know, get it working. Trying to, like, break out so that I can access, you know, what the other thread, what's happening on the other processor. So the grab is there. By delegating the PNG file creation to a specific worker, if MSS ever creates PNG files, you're doing it wrong. You know? I just don't know why, you know, why I'm getting these fucking frames, these low-ass frame rates. The grab method is what you want. Grab? Okay. What am I using? When I pull a, this is the wrong thing. Wrong project. So, return np.array sct grab the area. And is that how I'm using it? Screenshot, and I'm handing it the area, and then it's grabbing the area. And down here, screenshot, grab the area, and then it returns it to me. Yeah. I mean, that's the other thing, is that I could be fucking things up by having this as, like, a call where it does this declaration of MSS as SCT every time that I call screenshot. They import for their benchmarker, they import frames per second was the last time, well time, like when do they instantiate? Where are we doing this? Screen record, efficient, 40, 0, 800 by 600, MSS, FPS, benchmark. SCT equals MSS.MSS. And then when are you actually taking the shot? Image equals numpy.asArray sct.grab mon, which is the area. So you're just doing... Wait a second. Are you initializing MSS every time you call it? Literally what you just said. I mean, we can see... Happy New Year, Nomaru. We can see about that. if that's gonna make a difference. Alright, fuck it. We won't call screenshot. We just won't call screenshot. Instead, when we instantiate, we will do, what? A thing. You know, they like SCT. Alright, SCT is equal to MSS.MSS. Boom. So we've got that, and that's just when we instantiate. And then whenever we take a screenshot, what we want to happen is what they're doing over here, which is where? Okay, so you want the image to come out as a NumPy array. Not sure about that. Is that how I was doing it before in screenshot? NP array, SCT area, yeah. So that's what we want. So when we take a screenshot, which is going to be FG is equal to, not screenshot, we're going to have to give it all this shit ourselves. The area, view my area. FG is equal to np.array of sct.grab, and every time we do that, it'll be generating the and then the and let's do that up here as well. Not that it necessarily matters, and then we'll restart it, and we're 31 frames per second. We managed to ramp up to about 30 frames per second, which... And then if I added back in the actual processing... And also... similar percent... Hey! You know, after it gets going, it seems to crank out 30 frames. Move you off of there. Move you back up a bit. Over to Clustertruck. We got things, and we're only operating. We're down to 20-some frames per second now between the live stream and playing the game, basically. It's just a shame. It's a damn shame. The limitations of these libraries, or just of the technical difficulty of apparently grabbing the frames. I'm curious if D3D shot is, you know, something that we could actually use. Because I have a suspicion like this looks like this is just, you know, the limitation of trying to grab 1080p using the method that they're implementing with MSS. But the D3D thing got up to 60 frames per second, and I wonder if D3D, if DirectX is not going to, like, pump out extra screenshots, when there's no new change, when there's no new frame to be, you know, processed. And if that's the case, then, you know, the problem is that once we have the screenshot and start operating on it, we lose, like, half of the space between that and the next screenshot. Again, we get down to 30 frames per second, which really shouldn't be happening, because, you know, when we take the screen capture, the grab out of this, we get up to 500 frames per second, or thereabouts. 420, right? 420 frames per second. So once we have the fucking data available, it should be able to process it and go, bing! And then, you know, it's just sitting there doing nothing, waiting for the screenshot to, you know, grab another one for us. In their example, they initialize it once and then call that single instance every cycle. You're making new instances every cycle. Yeah, and I guess it had a minor impact, you know? But it's looking like this tops out at 30 frames per second for a 1920 by 1080 screen grab. I mean, what less could we possibly be doing right here? When I had everything grayed out, it was just grab a screenshot and count, you know, do an if check. Grab the screenshot, do an if check. calcs +1. Grab a screenshot, do an if check, calcs +1. And it was like, all right, 30 frames per second. It's not good enough. It's not good enough, man. But D3D at least still has some possible, you know, use to it. The other thing is the multiprocessing. I mean, we're not... when it says the PNG file creation, like if the grab is going to take 30 frames per second, you know? The grab is going to take 30 frames per second. Then it doesn't matter like PNG file creation. We don't need to create a PNG file out of it. It would be nice if we could be grabbing the frame with one processor and then like handing it off and have, you know, another processor that was just waiting for an array to have something in it, and then it would grab it and process it, and then you could have, you know, two separate things doing separate things. That would be cool. But whenever I've tried to like implement that in SplitRP, you know, when I was looking at at multiprocessing as solutions, I couldn't wrap my head around how it was meant to be done, or if it was possible to break those events apart. Because it seems like multiprocessing in Python is the kind of thing where you have to basically like decide at the beginning of what you're doing, and have them all individually do their thing, and they can't really like they can't like speak to each other, they can't hand things off to each other. The data ends up in its own pipe, and it's not accessible to anything else until the multiprocessing event has stopped, was how I ended up thinking of that by the end of trying to figure out how the fuck it worked. And I may be wrong, but that's where I got with it, was that like multiprocessing is like, yeah, you can do it, but you know, each processor has to just be given a job at the beginning of starting multiprocessing, and then once they're doing their jobs, they're in their own rooms. For reference of screenshotting speed in Java, I get about 65 frames per second summing RGB colors, just as a random test, with 1600 by 900 on my crappy computer. If milliseconds matter, getting proper game memory reading makes much more sense. Well, that's not going to happen. People have tried. And Clustertruck is not reliable enough in the way that it uses its own memory space to get the values that we need. At least, you know, from that. And that's not something that I'm interested in anyway. You know, I like the idea of doing a screen capture. It just sucks because it means we can't do the full fucking screen capture. 1280, 720. Just out of curiosity, 1280 by 720, and then with our BG, if BG was equal to 0, 0 to 720. No. You would be 0 to 1280. And you would be 0 to 720. No, I think we want vertical first. It's always confusing with image files. And we're up to 60 frames per second. So right now we should be comparing just like, you know, this corner of the screen as it stands right now. So if we go into Clustertruck, I can't see that because it's behind the thing you guys get to see, and I don't. So if we go into Clustertruck, the comparative values. Okay, get real low while we're, you know, out of the level complete screen like we want them to. Sit here. And then boom up to 94s and 90s and 80s, high 80s and stuff. It's not like we can't do these comparisons, I see that we dropped down to 30-some frames per second there for a minute. Okay, it's actually, yeah, the CPU usage is pulling it down while I'm in game. That's the other problem with Python, I think, is that it just, it runs on the one CPU, and if that's the CPU that everything else is using. Damn limitations. And it's not, but the theory of the image processing itself is fine. It's just the grabbing. So that's where we're going to have to leave it, is that it's, you know, it's the grabbing. And it's not that we're going to leave it there, but that's, you know, it's going to take research in order to try and beat this thing down. Either I'm going to have to limit screen grabbing, you know, to very specific areas for each of these things in order to keep the frame rate up. Or we're just going to need a better solution than what we've got right now. Dead set on Python, says Laws. Yeah, because it's what I know. You know, it's what I built. I've already got the application built. This would be a ripping out all of the guts of it and shoving it in there, but I got the UI, yeah. It's not going to change platform. Mostly true. Queues help a lot, but it gets so ugly so fast, so ideally a worker thread should be agnostic. Trying to have things interact with each other while they're multi-processing or multi-threading, that kind of a thing. It's just not, it's not very, like, I don't think Python does it. I think Python just locks it out. Like, it creates a namespace and a variable space for each, like, thread and operation, and they just can't speak to each other, and they can't share information, and you can't have one doing a thing and then another one hand off to him, and, you know, like, you start doing a thing up here, and then as soon as he gets it, he'll start working on that, and So there's limitations here, but we have confirmed that, like, the premise of what we're doing is very strong, and when we don't have to actually worry about the grabbing of the screenshot, which is kind of down to, you know, relying on libraries that other people have built. But when we're working on, you know, just these simple premises of the code that I've come up with here for processing the data that we're collecting, you know, it works, and it works a treat. It works brilliantly. If I set FG back up to where where's one of them? But I don't really want you to do that. You know what I want? I want you accept FG and images red test. When we don't have to, like, load in those screenshots, these are our frame rates. And we're just doing the processing. So if we can find a way to get those screenshots in, then we can do the processing. And if we have to limit the area of the screen that we take in to something like 800 by 600, then that's what we'll do. But I am still intrigued by D3D shot. You know, we looked at it, and when we turned all the processing off, we got up to 60 frames per second. When we turned all the processing off for, like, didn't we get... We got up to 60 frames per second with MSS, too, didn't we? But, like, everything is peaking out at 60 frames per second. So my suspicion is that we're, you know, bottlenecked by the VSync. Which is fine. I don't want it to be like grabbing extra frames that aren't there on the screen, obviously. But I do need it to, like, there needs to be a quick transition of handoff to this thing that does what it does at 400 and some frames per second. In other words, does it in so few clock cycles that it shouldn't even be noticeable if you've got 60 grabs a second, and between those grabs, this process should be over and done, and could have done it 5 times. You know, it could have done it multiple times between those two, and you don't even notice. That's where we should be with this. I don't know why we aren't, except, you know, the screen capture. Except the screen capture. Try D3D shot region things, says UZV now. Yeah, that's the thing, is if we... There's the limitation of D3D with, you know, it's not going to necessarily support Windows 7 systems, or maybe it's just not as fast. I don't know. It wasn't very specific in the documentation about that. It said, you know, it's the fastest way of doing it on Windows 8.1 or better. Does that mean it doesn't work on Windows 7, or what do you... Damn it. Be explicit. Yeah, I don't want to go down this road any further right here, right now, tonight. I feel like this is the kind of thing where I just go off and I explore, you know, fuck around with these different libraries on my own, and then come back when we've got something working that we could build on. Measuring the exact performance of the Windows Desktop Duplication API proves to be a little complicated because it will only return new texture data if the contents of the screen has changed. That came directly from the D3D shot page you were on earlier that said 60 frames per second. By the sound of it, you are right. Cool. Because that's fine, as long as once it gives me the fucking screenshot, I can have it. I feel like there's some kind of fucking mud between those frames, you know? Like, you do that. Boom, 60 frames per second. Okay. You're done. You hand it off to this process. It could do this 3, 4, 5 times before you would even get to the point where you'd want to start firing up the next screenshot grab then. So why did it, when we had this process active, why did it drag that 60 frame per second down to 30? That doesn't make sense. And that's what needs to, you know, just be looked into. And if we can get with 720p, if we can get 60 frames out of MSS with 720p, then maybe having a smaller array will also help. Burping will, you know, like D3D shot seems to be the stronger module right there. It got to 60, MSS wanted to do 30 at 1080p. So if you know, if I'm going to try and build on something, I'm going to try and build on D3D shot first, I think, is basically it. But yeah, so it's limited to ostensibly VSync. Something on the screen has to change before it will update its own thing, and that's fine. Which tells me that my 60 frame per second, you know, VSync is 5859, which makes perfect sense. Cool. I feel like I got all the information. I feel good about this. I feel good about where we're leaving this. And I feel good about the promise of D3D shot. And, you know, if we do have to take a smaller area, smaller rectangle, I'd rather be doing it with D3D shot to see if we're going to keep steady at the 60 frames per second. Keep steady at the frame rate on the monitor. Whereas we were seeing with MSS, even at 720p, it was dipping down to 30-something frames per second and then coming back up depending on how much things were operating. So yeah, I'm very happy at whomever it was that recommended D3D shot back when I was first getting started, and I was like, well, I already found MSS, I'm pretty happy with it. You know, look at all the frames we're getting. A very good thing that that recommendation was made, but I think I'm happy with this, and I don't want to dig too much deeper tonight. So there's your problem. I found your problem. Sure, we can crank out 400 and some frames per second as long as we consume 50% of the CPU in order to do it, right? If I stop this, the live stream itself is taking about 20% of the CPU. So there's your problem. There's your problem. But I mean, we should still be able to, the fact that it can crank out that many, we should be able to do one real quick. That's all we're asking for. Take a screenshot, do that one, and, you know, stay at 60 frames. I'm not sure. Let's see. Sounds like you might want to make use of the D3D shot capture method that adds frames to a buffer, and you could grab the latest frame with d3d.get latest frame. The one where it was talking about... I thought that sounded like it was doing like a recording over the course of time. And then you could grab like the stack of frames from that recording. That's what that is. That won't work for us. The capture method is also threaded, non-blocking. So you simply call capture and move on to your usual processing and call get latest frame. Oh! And while you're doing your processing, that latest frame method should return the same frame each cycle until it's updated by the threaded capture method. Just take a screenshot. It's true. That's exactly what we're trying to do. Okay. So I could set it and... So you get it going. See, now that's something that I'd be willing to fuck with right here, right now. So let's put D3D shot back into the mix. So D3D we create in NumPy, and then D3D displays. We want the 0, 1. D3D screenshot. No. It essentially records the screen. You can set the size of the frame buffer in the D3D create method. Okay. So I presume that's going to be another thingamajigger. D3D shot Python. Screen capture for 5 seconds and grab the latest frame. So basically this. And I can just turn capture on and leave it on. And then I set how deep the stack is so that it doesn't consume a shit ton of memory. Or does it just consume a shit ton of memory? We'll start here, we'll worry about memory later. So just start the capture, I don't ever have to stop it. And get latest frame. So create D3D shot or D3D dot capture. Nothing more needed than just capture, start the capture, and then I can just do D3D get latest frame. Okay. So for the foreground then, rid of that. Foreground. Yeah, D3D.getLatestFrame. But we don't want the screenshot. And then this, we want to be up here. Start the capture immediately as soon as we get started. Turn it on and have it stop at the end of the splits. What is it you're doing exactly? This is Brad5100. We're working on a screen capture method for auto-splitting speedrunning in Clustertruck. God, that's a fucking loaded sentence, huh? What? I'm sorry? Would you like to restate? So, BG, no, we don't need to do that anymore. We will stick with 4580 on the resolution. D3D get latest frame for FG, and actually we don't want that there, we want that happening inside the shit that we be all with the doing, yo. So it would be here. Simple as that. Except for probably not. Well, hey there. Hey there. That's fucking consistently, and it's above 60 frames. And it's supposedly doing the processing. And how's our CPU consumption? Now, bear in mind we're using about 21% for just the stream, so we're looking at 15% CPU. Which is a lot. It's not a little amount. But we're also, well, I mean, fuck it. That's fine by me. 15% CPU for solid 60 frames? Not as good as I was hoping. I was hoping for over 100 calcs per second. Well, if it's limited to... Oh, yeah, that's right. That's right, it's not limited to that now. And we can get frames back by limiting it to 60 frames per second if we wanted to. All right, let's see how this performs under load. Just while I was dragging that, we dropped a couple of frames per second. Okay, under load. Come in. Yep, it's suffering already. It's starting to flag. Get out here. Oh, down to 39. 145, we land on the screen where things, you know, like generation is paused and we back up to 50. This isn't bad, though. This is promising. This is promising. This is, you know, in order to get similar results to this with MSS, we had to go down to 720p. And unless I've accidentally put us down to 720p here, we're doing good. We're doing good. Let's reduce our resolution, which actually it might put it under more load, I'm not sure. Let's go down to 9 by 16. Okay, so we're literally resizing the images that we grab to 16 pixels by 9 pixels. Put it under load. Basically the same. And then back up to 50 while we're here. Yep. Yep. Okay. And then, if the resolution was no change, 1920 by 1080, sorry you're not seeing this while I'm just making these little adjustments. If we don't reduce the size at all and it has to do all that processing across the native sized image. Yeah, it's even harder on it. But just the smallest amount of, like from here, 1920 by 1080, we could do, what were we doing before when we were being crazy? We had 16 by 9, so we could do 90 by 160. Yeah? And there's some good frame rates while we're just sitting here. Get it back under load. And back up to 50 when we're sitting here. Yep. Alright, this shows promise. There's promise that is shown here. Do you see the promise? Do you see the Do you see? Did you do d3d shot capture.create capture output equals numpy? I did. There it is. d3d shot dot create capture output equals numpy. Yeah. So is the capturing not getting the frames you need at higher resolution? You know what? At this point, it's not the capture. The capture's handling fine. It is doing the, you know, the grab. A-okay. A-okay. It's the processing now. It's the processing. I am still kind of, but it is our image processing that's pulling things down. So, just for the fun of it, again, we're going to pull out all of the processing that we do and run it like that. And we have infinite frames per second. And D3D, because it's only going to like update the frames in the background, like the documentation apparently says, you know, it's only consuming 7 or 8% of the CPU in the background while we're just looping through this stuff. So basically the only weight that is being processed, is that 1,000,000 times? Yeah, 1,000,000 times is the weight of this if statement. That checks to see whether or not we should print the frames per second. We get in over Clustertruck. Hang on. You just put it over here. We get into the Clustertruck. Level. okay, we can drive it down to below 1 million. So it's really just like the efficiency of Python at this point. I mean, these methods are incredibly fucking lightweight. Or just very efficient methods that we put in here. Don't want you, right? Everything else still works? You know what I needed to do? Is just back up so that I end up with all the things back where I want them. Yeah. Which means we'd have to reduce the area that is being processed, I believe. But I'm happy. I'm happy with that. That shows a lot of promise. The D3D shot is actually working, doing its job. It's not getting in the way of anything else. Sure, we can process 400 frames a second when we're not grabbing any image. But functionally, we're really not grabbing any image here either. It's still weird, isn't it? It's still weird that we drop down to this many frames per second. It's the D3D it's got to be interplay between D3D shot and our process and our what we're doing to it. Hello, smoked salmon. I think I'm wrapping up for the night though. I'm happy. I'm happy with this. Lots of promise here. Don't know what I would do differently, really, because it's a very simple kind of set of things. We're converting a color space down to gray. We found that increases our processing power. Like, basically, we would have to just cut down, even if we're grabbing the image at full screen, it looks like we're going to have to analyze it at a smaller... It just doesn't make sense. It keeps burning my brain up because I keep thinking, well, we'll just have to cut down into a smaller area of the screen. But we're resizing. So is it the resize itself that's fucking taking the time? We tried it without any resize earlier. The resize was helpful. The resize saved us processing power. It saved us time on this. We did that, like, that was one of the first things that we looked into. So, I mean, yes, the resize takes processing power, but it saves us, presumably on this summing process, this subtraction, where it has to go through every single thing and add it all up. So instead of having to go through 1,920 times 1,080 pixels, it has to go through 90 times 160 pixels and do the subtraction across all those and update all of those in their table space. Looking for just one certain color, says White Ops. I have been grayscale converting it, which made things easier. Although now that you say that, could actually reduce the load of the grayscale conversion by just peeling off one color channel and ignoring the rest. I mean, it's a smaller set of data, obviously, but I don't think the color space conversion is really hurting it. We only have to do that once. In fact, we can just take that out, can't we? And it doesn't break, it just screws up our percentage rates. It breaks because you've got it named the wrong thing. If I just did gray FG is equal to FG. Out equals small FG minus small BG. Operands cannot broadcast together because they've got different shapes. Okay, so then... Yeah, we've been down this road. I don't need to do it again. We've been down this road of playing with, like, the color spaces and things like that. We did that earlier. Should just look for one certain RBG channel. I need, I'm going for an accurate estimation of the similarity between two different things and two different images, and we could probably get away with that in a lot of instances. I might as well thresh everything down to black and white, though. But that would be easier. That would be less CPU intensive. But I just don't think that that's that CPU intensive in the first place. We were doing this on the 3 color channels, and it wasn't that hard on it even. But maybe. 9163 versus 9160 is one being rendered in 3D. The 3 are the 3 color channels, RGB, and so I was just taking out the processing it down to grayscale. So one of them was still being processed to grayscale, the other one was not. But I don't need to go down that road. We looked at that shit earlier. And we've been here for 4.5 hours. I am happy with leaving it right here too. I'm not disappointed. I'm not like, shit, this isn't going anywhere. We got this thing up to, 70 frames per second using these methods. Once it's under load, it drops down as low as 30 frames per second, 35, I think. But it's got promise. It's got promise as the new engine for, SplitRP that already exists, and you just reach in and start ripping out wires. And I wanted to redesign my method for sort of the pass through, the fall through from one area of the game to the other. If you're running the levels, then there's only certain screens you need to look for. The pause screen, maybe the menu screen, and the level complete screen. But when you're on the menu screen, you want to be looking for the back out, the further deeper menu screen. So there's different things. So there's a very complicated system that I set up for that, that just kind of allows one area to drop through to the next and drop through to the next and drop through to the next. And it's a bit of a tangled web. It works, but it's really hard to penetrate, intellectually. So I kind of wanted to rewrite that, and even if it's like technically less efficient, I don't care. Like, it needs to be simpler, more legible, clearer. So I'm fine with that. The third dimension would be the 3 color channels. That's correct. I was just wondering, when summing up the difference array, wouldn't you need to first take absolute values of this array because there could be negative differences? Apparently. And you're damn right. Apparently, though, it's like absoluteness is just a part of, I'm guessing, NumPy's image-based array. Like, it will not go negative. Maybe it's an 8-bit array, or whatever kind of array that NumPy is, it just won't go negative. So I was expecting to have to force absolute values, and I don't. And I'm getting accurate. I subtract the 2 from them, and there's just no negative on it. But you're still getting the difference between the two. So it works out. Presumably, the inbuilt system of that means that function is a little bit slower than it could hypothetically be, but I'm sure it's still a lot faster than I could write it, outside of the methods that are built in. Yeah, I was surprised to find that myself. But yeah, all I have to do is subtract one from the other and you get the difference, and there's no need to take off the negative side. This is good. This has potential. These methods work for what I was trying to get to in terms of being able to, estimate, to get a comparable percentage between 2 different images. And we haven't seen that in a while, like at work. And I really can't be bothered to hear. So instead, if I open up where we started here, the no green screen chroma key, yeah, sure, new fucking window. This is what we were building off of. Unless I put the screen grab into this already. Please don't tell me I did. I didn't. So this is what we were building off of. BG versus streamer. So I've got red, and I've got redtest.png, and these two things compare them. Red is just a red background. Red test is a red background with a blue circle in it. This is the difference between the two of them at a resolution of 90 by 160. So we're taking the full 1920 by 1080 image that's already stored on the disk, and then we're shrinking it to 160 by 90. And then we're comparing those two images at 160 by 90 by merely subtracting one from the other, and then, you know, calculating the sum of all of those different pixels divided by the number of pixels and so forth and so on, down to a percentage value, 98.7%, which is incorrect, isn't it? Maybe it's not. Maybe it is. Maybe it's not, but maybe it is. And this is doing the grayscale thing. We've done it in color before as well. Color works just as well. It's just a bit slower. So I decided to focus on grayscale as we're testing through this stuff. But that's where we started today, and where we ended was we have the application watching, you know, the fucking screen and reporting every 1 second what the match is to what it's trying to match against, and what it's trying to match against is this, which means if I could get that, can I get you, like, just to show me at full screen? There you go. That should be a perfect match. So I can't see. Really? I can't tell. But you could, is that a perfect match? Was it telling us a perfect match? If I go over here, 99.99937, because that's what it's trying to compare against. So whatever's on my screen, it's comparing against that, and the figures that it's giving us back are very useful. And that is all toward the end of being able to have a splitter like this running in the background, looking so that when we hit the level complete screen, we start seeing 90% values, high 80s, low 90s, and then we can know, okay, that's a level complete screen, hit the split button, and also pause timing. And then when we leave, the first time that we see a, you know, sub 60% value or something like that, we know, okay, we must have left the level complete screen. So, restart timing. Oh, we just hit a level complete screen. Stop the timing again. And that will allow us to have the IGT percent of my trains. 99.993, but I'm happy. I'm happy, and I'm going to close down the live stream. Thanks for coming out and sticking around with me while I tinkered with all this insane premises, this ridiculous code. You know, the program's already built, the user interface is there, a lot of methods are already established, objects and things. If this engine were to be made, you know, nice and stable and solid and quick, as quick as the pixel-based method that I was using, the edge and plane detection that I was using before, if I could get it up to that, I feel like it would be easier to use, more consistent, more reliable, easier to just, you know, to adjust and be like, oh, that's not working here. I'll just tweak these values and boom, now it's working again. So I would much prefer if this were the core and the heart of SplitRP, if this were at the bottom of it. And it would, if it worked, it would probably be the thing that got me to start finishing it, as opposed to what I've been doing, which is just, you know, putting it off like I do. I am the Ronin Bull. Law's asking, am I likely to do other programming live streams? This was good fun. I'm afraid of it. I'm afraid of it. People want to see me speedrun. They want to see me Mario. They want to see me Clustertruck. They want to see me naked. No, that's my other channel. But you know. But if I start working on it again, there will be the occasional programming stream. Yeah. I mean, basically, I have no idea. I have no idea what I'm going to do. No one does. You should know that by now. Thanks for coming out. We'll be back. I don't know, maybe tomorrow. Maybe tomorrow. Sometime around 4 p.m. Eastern. Maybe earlier. I prefer earlier. In any case, I am the Ronin Pawn. And, what do we say? Pawn out!